want to learn electronics but don't know where to start. You've been studying the course but can't seem to understand its complexity. Either way, this series is made for you. Come and join me as we explore the world of electronics from the ground up. I am Errol, and this is the Erolectronics series. Before I discuss the topics that are included in the first module, let me first emphasize that these topics shall build upon each other. This means that understanding the previous topics is crucial to understanding the next topic. Module 1 covers electron theory. This includes an explanation of what is meant by an atom, an element, a compound, and a molecule. It also includes the composition of an atom in terms of electrons, protons, and neutrons, and the importance of the balance between protons and electrons. This module also covers semiconductors. This includes the definition of a semiconductor and an explanation of how semiconductors are being utilized. Next, it covers semiconductor devices. This includes an understanding and acquisition of knowledge about various power semiconductor devices. And lastly, this module covers diodes, which includes an explanation of the constructional features, operating principle, characteristics, and specification of power semiconductor diodes. It also includes an understanding the basic operation of diodes in AC circuits and solutions to basic problems in half-wave and full-wave rectifier circuits. Those will be the topics under this module. Now probably, some of you are asking or even wondering, that sounds like a mouthful. It seems there are too many topics to be discussed for Module 1. Don't worry, I'll try to deliver the lessons little by little so that you will be able to understand and comprehend the topics that we will be discussing. With that, see you on our next one. In the previous video, we have discussed the roadmap as we move forward through Module 1. In this first lesson, we'll talk about electron theory. Hi, I'm Errol. Welcome to the Erolectronics series, where we explore the world of electronics from the ground up. In this first lesson, the student shall be able to explain why there is a need to learn electron theory. Next is explain what is meant by an atom, an element, a molecule, and a compound. Next is to explain the composition of an atom in terms of electrons, protons, and neutrons. And lastly, explain the balance of electrons and protons. So if this interests you, please keep on watching. This was the roadmap that we discussed on our previous video. Now, let's dig into electron theory. Here we will explore the reasons for studying electron theory and the various terms related to our topic. So, why do we need to learn electron theory? According to Malvino and Bates 2016, in electronics, all that matters is the outermost orbit. We can compare the significance of the outermost orbit to how Filipinos distinguish a salted egg from a regular egg. By just looking at the characteristics of the outer surface of the egg, which in this case is colored red, we will be able to decode the property of the egg, which in this case is salted. In the case of the outermost orbit, by looking at the characteristics of the outermost orbit, which is part of the atom's structure, we will be able to decode the electrical properties of a given element. Now, what are the various terms related to electron theory. Shown here are the four terms that are associated with electron theory: element, atom, compound, and molecule. Now, what is an element? One definition of an element is proposed by Robert Boyle, saying that elements are substances that could not be reduced to something simpler. To add weight to this, Lavoisier asserts that it is the final stage of analysis. John Dalton brought something more fundamental to Lavoisier's definition when he asserted in 1808 that the specific properties of elements are derived from those of their constituent atoms. This is connected to what we established a while ago: the outermost orbit, atomic structure, electrical property. In other words, the electrical property of a material is derived from the structure of the constituent atom. And in Mendeleev's time, the periodic table is drawn, which arranges these elements according to their unique elemental weights. Now let's look into the periodic table. Let's say we have the element copper. According to Boyle, it cannot be reduced to something simpler. Basically, this means that copper cannot be made by combining other elements found in this periodic table. In other words, it is the final stage of analysis. Understanding the characteristics of its atomic structure, we will be able to understand its properties. We will see this later, so stay tuned. Lastly, copper is unique from all other elements. Since all elements are unique, each of these elements also have a unique atom. When atoms of the same element combine, it will form what we call a molecule. On the other hand, if atoms of different elements combine, it will form what we call a compound. And a compound is a molecule. To illustrate this, say we have an element, hydrogen. This element has a unique hydrogen atom. When two atoms of hydrogen combine, it will create a molecule of hydrogen gas. On the other hand, if atoms of hydrogen combine with oxygen, it will create a compound known as water. Water is also a molecule, but hydrogen gas is not a compound. So goes the phrase, all compounds are molecules, but not all molecules are compounds. Atoms come from the Greek word atomos, which means indivisible, since early scientists believed that it cannot be broken down into smaller pieces. But later, this was refuted through the discovery of the subatomic particles. Subatomic, the prefix sub means smaller. Therefore, subatomic means smaller than atoms. So what are these subatomic particles? The subatomic particles are composed of the negatively charged electrons, the positively charged protons, and the no-charged neutrons. Both the protons and the neutrons are found at the atom's center, also known as the nucleus, in accordance with the planetary model of an atom. To illustrate this, the blue spheres in this photo are the electrons, and the red and yellow spheres are the protons and neutrons, located at the center. Notice that the electrons are traveling in circular orbits. Notice also that there is more than one orbit, and as you go farther away from the nucleus, the orbit becomes larger and larger. Now, let us go back to why we are studying electron theory. Shown here is a tile of a copper atom found on the periodic table. Its atomic number is 29. This means that it has 29 protons in its nucleus. It is important to remember that for a pure element, it has an equal number of protons and electrons. This means that there are also 29 electrons traveling around the nucleus. Previously, we stated that electrons travel in orbits. What I forgot to emphasize is each of these orbits have a capacity as to the number of electrons that can orbit through it and is governed by the equation 2n squared, where n refers to the nth orbit. So let's say for the first orbit, here our n is equal to 1 since we are on the first orbit. So 2 times 1 squared is equal to 2 electrons. Therefore, on the first orbit, the maximum number of electrons that can fit are only 2 electrons. Now next, for the second orbit, where n is equal to 2, 2 times 2 squared equals 8 electrons. Okay, therefore, a maximum of 8 electrons can occupy the second orbit. Since the first orbit, we have already 2 electrons plus 8 on the second orbit, so we have now a total of 10 electrons. Now there are 29 electrons for a copper atom. We still lack 19 electrons. Therefore, there is a need for a third orbit. So if n is equal to 3, 2 times 3 squared is equal to 18 electrons. Since we need 19 electrons, we still lack 1 electron to complete our illustration. So there is a fourth orbit, and on that fourth and final orbit, we only have 1 electron. We call this outermost orbit the valence orbit, while the electron present in this orbit is called a valence electron. The number of valence electrons will determine the electrical property of an atom. Remember what we discussed previously: outermost orbit, atomic structure, electrical property. For copper, it is a material used to create electrical wires. In other words, the electrical property of a copper atom is a conductor. If the valence electrons is less than 4, then that atom is a conductor. Since copper has only 1 valence electron, it is one of the best conductors found on the periodic table. On the other hand, if the number of valence electrons is greater than 4, that atom is considered an insulator, and the best insulators have 8 valence electrons. And for the purposes of electronics, if the number of valence electrons is equal to 4, then that atom is a semiconductor, which is our next lesson. To recap, we learned why we need to learn electron theory, outermost orbit, atomic structure, electrical property. We also explained what is meant by the following terms: element, atom, molecule, and compound, where each element has a unique atom, and when atoms of the same element combine, it will create a molecule, and when atoms of different elements combine, it will create a compound. We also emphasize that all compounds are molecules, but not all molecules are compounds. Next, we also explain the composition of atoms, otherwise known as the subatomic particles: the positively charged proton, the negatively charged electron, and the no-charge neutron. And lastly, we explained how the pure elements have a balance of electrons and protons as indicated by the atomic number. That ends our first lesson, and I'll see you on our next one. Imagine this. You just ordered yourself a brand new computer from an e-commerce store. But instead of receiving a small box on your doorstep from Lazada or Shopee, you have a delivery truck full of boxes to deliver. And not only that, but there's also a bunch of support technicians walking into your house. From what they said, it sounds like they'll be there for a few weeks to get this new computer of yours up and running. While this might seem crazy by today's standards, it's exactly what the process for setting up a computer in the 1940s. And good luck fitting those things in your home. Computers in the 1940s often took up an entire room, weighed many tons, and required constant air cooling to keep all of their vacuum tubes working. Point being, the small computers that we know today, and even your cell phones, the ones that we can slip into our backpacks or feel in our pockets or strap onto our wrist, are just a shadow of the beast from yesterday. And this entire miniaturization process that we're all reaping the rewards from would have never been possible without semiconductors. In the previous video, we have discussed about electron theory and its relation to electronics. In today's session, we will talk about semiconductors. Hi, I'm Errol. Welcome to the Erolectronics series, where we explore the world of electronics from the ground up. In this lesson, the learner shall be able to explain how semiconductors are being utilized, define the term semiconductor, differentiate a semiconductor from a conductor and an insulator in terms of its properties, and lastly, explain the types of semiconductors. Without further ado, let's start. This was a roadmap for Module 1. Now, let's dive into semiconductors. Here we will discuss how semiconductors are being utilized, what semiconductors are, and its properties. Along the discussion of the properties of semiconductors, we will be comparing it to insulators and conductors in order to highlight its significant difference, which led to its wide acceptance in electronics. And lastly, we will discuss the different types of semiconductors. Let's start with how semiconductors are being utilized. Shown here are 4 examples of how semiconductors are being utilized nowadays, particularly in the entertainment, healthcare, telecommunications, and transportation industries. The thing is, semiconductor utilization in these industries are often easily taken for granted. After all, when we buy these electronic items, all we ask the sales agent is whether they have the Model S car, a 50-inch TV, or a 4G smartphone. We rarely think about the fact that underneath the hood of that car, the panel of that television, and the casing of that smartphone are the electronic components made of semiconductors. Basically, anything that is computerized or associated to communication circuits utilize semiconductors. Since computers and communications devices are also needed in maritime vessels, various electronic devices are now installed on board modern ships. These include an autopilot system, also known as a self-steering system, which coordinates data from many devices on the ship to keep the vessel on a predetermined course. Another electronic device is the gyro compass, which locates the correct north direction and is unaffected by external magnetic field. Next is a radar, which detects targets and displays the information on the screen to avoid collision. And a chart plotter, which combines GPS data with an electronic navigational chart to display the position, heading, and speed of a vessel. All of these electronic devices are found on the deck department. For the purposes of the engine department and this basic electronics course, ships also utilize several power supplies. But this picture of a power supply may not be familiar to you, so let's change it to something that is common. A cell phone charger. This charger is actually a direct current power supply. We will be dissecting and learning about the various sections of a DC power supply as part of this series. By the way, subscribe to this channel if you are not yet subscribed and ring the notification bell so that you will be updated on our latest uploads. If this video has been helpful, please leave it a thumbs up to help it reach its intended audience. Now that we have established how semiconductors are utilized in electronic devices, let's now move on to what semiconductors are. According to Malvino and Bates, a semiconductor has an electrical property that is between a conductor and an insulator. On another note, Boylestad and Nashowski defined a semiconductor as a material with a conductivity level between a conductor and an insulator. Both these authors of electronics book support what we have learned in the previous video about the property of a semiconductor, which is on valence electrons. So, let's review. We learned that the number of valence electrons will tell us what the electrical property of an element is. Less than 4 valence electrons means it is a conductor. Greater than 4 means it is an insulator. And lastly, if it has 4 valence electrons, it is a semiconductor. Now, shown here are the various planetary model or orbital diagram representation of the electrons of each given element. We have here silver, aluminum, gold, nitrogen, neon, sulfur, silicon, germanium, and carbon. Now, if we focus our attention on the valence orbit, it is clear that silver, aluminum, and gold are conductors, with silver and gold having 1 valence electron and aluminum having 3 valence electrons. That is why a computer's processing unit or CPU utilizes golden pins, since gold is a better conductor of electricity than copper. We can also conclude that nitrogen, neon, and sulfur are insulators, since the number of valence electrons is greater than 4. These elements are actually considered non-metals. That is why it is a bad conductor of electricity. Finally, we have silicon, germanium, and carbon as semiconductors. There is actually a shortcut in determining the number of valence electrons, and we will be using the periodic table. Shown here is the periodic table. Before I discuss the shortcut, I'll give a disclaimer first. The shortcut that we will be discussing is only applicable to these elements. In other words, these elements here, called the transition metals, is an exception to this shortcut, since finding the number of valence electrons for these elements needs a thorough understanding of the electron configuration, which we will no longer tackle in this course. By just looking at the group name or the column name, we will be able to tell how many valence electrons an element has. If it is in group 1A, it has 1 valence electron. If it is in group 2A, 2 valence electrons, so on and so forth. Notice that carbon, silicon, and germanium belong to group 4A. As such, we can tell that it has 4 valence electrons. Nitrogen has 6 valence electrons, neon has 8 valence electrons, and sulfur has 6 valence electrons. The next property of a semiconductor that needs to be explained is the energy band. Before we explain the energy band model, we'll start with something that we are already familiar with. Here, we have the nucleus, the valence orbit, and the valence electron. Now, another characteristic of subatomic particles is the attraction of the electrons to the nucleus, since opposite charges attract, the protons in the nucleus being positively charged while electrons being negatively charged. But due to the centrifugal force created by the orbiting electrons, they remain stable in their respective orbits, much like satellites orbiting the Earth. Due to the distance of the valence electron from the nucleus, its attraction to the protons at the center is weaker. Remember that the valence electrons are found on the outermost orbit. In other words, the larger the orbit of an electron, the weaker is its attraction to the nucleus. When a valence electron gains enough energy due to, for example, a rise in temperature, it has a tendency to leave its parent atom and become a free electron, leaving behind a vacant hole in the valence orbit. To better explain this phenomenon, we use the band model. In this model, the vertical axis represents the energy level of an electron, and instead of a valence orbit, we have a valence band where the valence electrons are located. This model also has a conduction band where free electrons are located, and in between the valence and conduction bands, there is a band gap, also known as the forbidden energy band. As you may observe, there are no free electrons in the conduction band at the moment, because this is the band model for an insulator. Shown here are the band models for a semiconductor and a conductor. If we look into the band model for a conductor, we will observe that the valence and conduction bands overlap. This means that at a certain energy level, in this case, this line over here, we can call the valence electron also as a free electron. In other words, the two terms, free electron and valence electron, becomes interchangeable. It is different for semiconductors and insulators because there is a forbidden energy band or band gap that must be crossed first before the valence electron becomes a free electron. We can think of the forbidden energy band as a toll gate, where before you can pass through, there is a need to pay a certain amount. In the case of valence electrons, its energy must exceed a certain level first, typically 1 electron volt for semiconductors and 15 electron volts for insulators, before it goes into the conduction band. What's interesting about semiconductors is that when a valence electron reaches the conduction band to become a free electron, it will leave a hole behind on the valence band, and these holes are associated with a positive charge. For now, remember that holes are positively charged and the free electron, being an electron, is negatively charged. We will be using this later. At absolute zero temperature, all valence electrons are on the valence band, resulting to no free electron in the conduction band. Thus, semiconductors act as insulators at this temperature. On the other hand, if a semiconductor is subjected to high temperatures, valence electrons become excited and gains enough energy to cross the band gap and become a free electron ready for conduction. Thus, at high temperatures, a semiconductor acts as a conductor. Therefore, a semiconductor can act as a conductor or an insulator depending on the temperature. Now that we have provided an evidence that the property of a semiconductor is between an insulator and a conductor, Let us now discuss the types of semiconductors. A silicon ingot is basically silicon that is 99.999999999% pure, the so-called 11 nines. We will discuss why it has to be this pure later. Now, according to Malvino and Bates, many years ago, germanium was the only material suitable to make semiconductor devices. But because of its fatal flaw in terms of excessive reverse current, silicon became practical and made germanium obsolete in most electronic applications. After all, silicon is also the second most abundant element on the earth, next to oxygen. That is why we hear the terms Silicon Valley and silicon economy nowadays. Shown here is the orbital diagram of a single silicon atom. Now, an ingot is comprised of many atoms of silicon like this, which arranges itself into a pattern known as a crystal. If we zoom into the silicon ingot, we will see silicon atoms side by side one another. In order to create the solid structure of an ingot, these silicon atoms must share electrons to its neighboring atoms to create a covalent bond. Atoms have a tendency to prefer to have 8 valence electrons in the valence orbit. This rule is known as the octet rule, from octagon or octopus, associated with the number 8. Remember that silicon has 4 valence electrons, and it needs 4 more to complete the 8. As such, it needs the contribution of the neighboring silicon atoms. To illustrate this, a silicon atom will have 4 neighboring silicon atoms in a crystal, and each of these 4 atoms will share 1 valence electron and create a covalent bond with this central atom. To better understand the sharing of electrons, the valence electrons of the central atom are colored red to distinguish it from the electrons shared by the neighboring atoms that are colored in yellow. Thus, there will be a total of 8 valence electrons for the central atom. And since this is a crystal, this same process happens to each of the neighboring atoms, meaning the neighbors of this silicon atom, which is this one above on the left and below, will also share electrons. This covalent bond produces chemical stability that results in a solid piece of silicon ingot. Since all atoms in the crystal are silicon, we call this an intrinsic semiconductor. Now you may ask, isn't it said that when there are 8 valence electrons, the electrical property is an insulator? Well, we are not done yet. As what we have discussed in the band model, in order for valence electrons to enter the conduction band, it must have sufficient energy, which may be provided externally through the application of heat to increase the temperature. Once an electron gains enough energy to pass through the band gap, it will leave the parent atom and become a free electron, leaving behind a positively charged hole in the valence orbit. This hole will be occupied by another neighboring electron. Remember, opposite charges attract. To illustrate this, suppose we have this valence electron excited such that it leaves its parent atom to become a free electron. After leaving its parent atom, it will leave a vacant hole behind that is positively charged and attract neighboring valence electrons. This phenomenon of a vacant hole filled up by another electron is known as recombination. When a neighboring valence electron leaves its parent atom, it will also leave behind another positively charged hole. Another neighboring valence electron recombines with this hole, and even valence electrons that are on the same valence orbit or neighbor of the central atom. Thus, there will be a flow of holes and electrons within the semiconductor, specifically flow of free electrons in the conduction band and flow of holes in the valence band, as indicated by the arrows in this illustration. Take note that the flow of holes is opposite to that of the electrons. You may have noticed that when a valence electron recombines with a hole, that hole will transfer to where the valence electron has left off. That is why the flow of electrons and holes is opposite. What makes semiconductors interesting is that one can change the electrical property of a semiconductor by adding a different atom, otherwise known as an impurity atom. This process of adding impurity atoms to intrinsic semiconductors to change its electrical properties is known as doping. And we can add either a pentavalent atom or a trivalent atom. For pentavalent atoms, this can be arsenic, phosphorus, or antimony, which are pentavalent atoms. Penta as in pentagon, which means 5. As such, pentavalent means atoms with 5 valence electrons. Upon adding a pentavalent impurity atom to the intrinsic silicon crystal, we also add an extra 1 electron that is not part of the covalent bond. To illustrate this, suppose we have added arsenic into the crystal at the position of the central atom. The 4 valence electrons of arsenic will create a covalent bond with the neighboring atoms, while the remaining 1 electron will automatically be of higher energy level since it is not part of the valence orbit and consequently not part of the valence band. Is this electron automatically a free electron just like for a conductor? Not necessarily. In accordance with the band diagram, this donated electron's energy is just nearer to the conduction band compared to the valence electrons. Thus, it requires a lesser excitation for it to reach conduction band. Since adding this pentavalent atom contribute to an additional free electron upon lesser excitation, we call this atom a donor atom. The number of donor atoms added will determine whether the crystal is lightly doped or heavily doped. Being heavily doped means more pentavalent atoms and therefore means more conductivity upon excitation. Because of the additional free electron every time we dope the crystal with pentavalent atoms, we also create what we call an N-type semiconductor. In other words, a pentavalent atom is also a donor atom and creates an N-type semiconductor. This just means that negatively charged particle free electrons are greater in number compared to the positively charged holes. As such, free electrons are the majority charge carriers, while holes are considered minority carriers. Since we added an impurity atom to the silicon crystal, the semiconductor will now be called an extrinsic semiconductor. In other words, a doped semiconductor is an extrinsic semiconductor, while a pure semiconductor is an intrinsic semiconductor. On the other hand, adding trivalent aluminum, gallium, and boron to intrinsic semiconductors creates a p-type semiconductor. Trivalent from the word triangle or tricycle. Tri means three. Three valence electrons. Trivalent atoms are also known as acceptor atoms. We will see later why it is named acceptor. Thus, in p-type semiconductors, holes are the majority charge carriers and free electrons are the minority charge carriers. Upon adding a trivalent impurity atom to the intrinsic silicon crystal, we will lack one electron to complete the octet in the valence orbit. In other words, a hole will be created. To illustrate this, suppose we have added boron as dopant into the crystal. At the position of the central atom, the three valence electrons of boron will create a covalent bond with the neighboring atoms. This leaves one of the silicon atoms to have an unpaired or unbonded electron. Because we lack one electron for boron to bond with the other silicon atom, this creates a hole in the bonding structure. Notice that we did not put the hole on the valence orbit as what we did previously, since in accordance with the band diagram for acceptor atoms, this hole has an energy that is nearer to the valence band. And since this hole is positively charged, it will attract valence electrons to it. When this happens, a hole is created in the valence band which awaits recombination from neighboring valence electrons. Thus, aside from the free electrons created when a p-type semiconductor is excited, more holes are created every time a trivalent atom is added. In other words, the number of holes is greater than free electrons. This is the reason why holes are the majority charge carriers for p-type semiconductors. And since holes are positively charged, technically, it accepts nearby valence electrons during recombination. That is why these trivalent impurity atoms are also called acceptor atoms. The doping of pentavalent and trivalent atoms to intrinsic semiconductor to create an extrinsic semiconductor is the reason why silicon ingot is of high purity. Again, the 11 nines, in order to control the conductivity of the resultant semiconductor material after the doping process. That ends our discussion for this lesson. To recap, in this lesson, we explained how semiconductors are being utilized, particularly in today's context where we have flat-screen TVs for entertainment, handheld gadgets like smartphones for telecommunications, and electric vehicles, and how easily we take for granted semiconductors in these industries, much like a visual effects artist in a sci-fi film. We also explained how semiconductors are utilized in the maritime industry. We also defined what semiconductors are and emphasized its characteristic of being in between that of a conductor and an insulator. Next, we differentiated a semiconductor from a conductor and an insulator in terms of its properties, particularly on valence electrons and energy band model. Lastly, we explained the types of semiconductors. In terms of being pure or not, we have intrinsic and extrinsic semiconductors, and in terms of majority carriers, we have an N-type and P-type semiconductors. That ends our second lesson, and I'll see you on our next discussion on semiconductor devices. Take a look at these pictures. I'll give you 5 seconds. Have you found the deeper meaning behind these photos? Were you able to decode the message that it is trying to impart? A picture is worth 1,000 words, goes the famous saying. Throughout human history, we have used pictures to convey ideas, express ourselves, and present information. Basically, we have used pictures to communicate. However, different people and cultures use different types of pictures to communicate ideas. This was a problem that faced our engineers, designers, builders, and architects throughout history. We didn't have one way of communicating our ideas that everybody understood. Gaspard Monge faced this problem when he started as an engineer in the French military. And so, he devised a system that could be used to communicate an object to anyone across the world. This system is called orthographic projection and was quickly adopted by army engineers. Shortly, this system spread and revolutionized world industry. Such was the history of engineering drawing. Good day, Nixers! I am Errol and welcome to the Engineering Drawing series. In this first module, we will be learning about engineering drawing. Specifically, what is engineering drawing and why do we need to study it? Next, we will be discussing about the various types of engineering drawing, including an assembly drawing, a component drawing, and a pictorial drawing. We will also be discussing about the various types of lines used in engineering drawing. These include an object line, hidden line, section line, center line, dimension line, extension line, leader line, cutting plane line, phantom line, and border line. Lastly, we will be discussing about projections, including isometric and oblique projections. Those will be the topics under this module. Now probably, some of you are asking or even wondering, do we really need to know all this stuff? I thought we will only be drawing things in this course. Well, most of the time, we will be drawing. The key here is for us to understand why we do what we do, why we need to spend our precious time drawing things throughout the duration of this course, why we need to use different types of lines in our drawings, and the essence of various projections of a three-dimensional object. After all, engineering drawing is the universal language of engineers. That would be all for this introductory video, and I'll see you on our next one. Okay, so good morning to each and everyone. So we will now be starting our discussion for the subject NGEP 9, Math, Science and Technology. Okay, so for the course outline of the subject, it will be divided into three major topics, namely trigonometry, solid mensuration, and integral calculus. Okay, so these are three different mathematics subjects nung dati. Okay, so trigonometry is Math 2, solid mensuration is Math 3, and differential and integral calculus way back was Math 4. But today, or in this particular course, in NGEP 9, it is actually lumped into a single subject. Okay, so we will now go into the first lesson, okay, which will be about trigonometry. So we will divide trigonometry into these three major lessons, okay? So itong naka-blue will be one lesson. Second lesson will be about oblique triangles, okay? The third lesson will be about spherical triangles. Okay, so we'll start with the basic angles and measurement, okay? Then ano-ano yung mga trigonometric functions involving angles, and then if papahanap sa yung trigonometric function values, paano natin makukuha yun, okay? Then also the solutions on right triangle, okay, using Pythagorean theorem and sine cosine of real numbers, okay? Without further ado, okay, let's go to the intended learning outcome for this first lesson. Okay, again, there are three major lessons for trigonometry. This is the first lesson. Okay, so at the end of this lesson, the student shall be able to convert angles in degrees to radians and vice versa. Okay, so pag binigyan tayo ng angle na naka-degree, okay, convert natin into radian measurement, or the other way around. Given tayo ng angle in radian measurement, okay, i-convert natin into degree measurement. The second is find the missing side of a right triangle using Pythagorean theorem. Okay. And third is identify and evaluate the 6 trigonometric functions of a given angle. So pag given tayo ng certain angle, ano-ano yung 6 trigonometric functions na pwede nating makuha. Okay. And then evaluate the angles using inverse trigonometric functions. Okay? Coming from the 6 trigonometric functions, pili tayo ng isa, and then kunin natin yung value ng missing angle. Okay? So, ito yung kailangan nating ma-build up. Okay? After the lesson, kailangan ma-develop natin ito sa inyo. Okay? Na kaya niyong gawin ito lahat. Okay? So, let's start. So, introduction to trigonometry. Trigonometry is a combination of two Greek words. Okay? It is actually a contraction, okay, ng dalawang words. Trigonon, which means triangle, and metria, which means to measure. So, basically, pag kinumbine natin yung dalawang words na yun, we'll have the basic meaning of trigonometry, which is the measurement of triangles. Okay, now, trigonometry is divided into two major types. Okay, we have plane trigonometry, and the second one is spherical trigonometry. So for plane trigonometry, meron din siyang dalawang branches. We have involving right triangles, and then the second one will be about oblique triangle or obtuse triangles. For spherical trigonometry naman, this will be involving spherical triangles. Okay. Now for the first lesson, we'll be focusing on right triangles lang muna. Okay? So what are the formulas? What are the things that we need to consider when solving right triangles? Okay? So angles and measurement. So first and foremost, what is an angle? So an angle is a figure formed by two rays sharing a common endpoint. Now let's explain, ano ba itong pinabanggit na two rays? So ito yan. So we have two rays, this one and this one. Okay? Sharing a common endpoint. So ito yan. So these two rays shares this common point. We call this the vertex. Angles are commonly represented by Greek letters. So makikita natin that when we solve problems later on, mapapansin natin that most of the angles are represented by Greek letters. Commonly we have alpha, this symbol, beta, theta, okay, and gamma. Okay, marami pang ibang Greek letters, but these are the most common ones that are being used. Okay, so for example, this particular angle, so pwede nating pangalanan ito na angle theta. Okay, so yan. Now, there are two common measures of angles, or two common units of measurement. We have degrees, and the second one is radians. Okay, now, these are the various types of angles. So I'm sure you have already encountered this on your previous topics in mathematics. We have acute angle, right angle, obtuse, straight, reflex, and full angle. I will not go into the definitions. Pwede niyong basahin yan. Now, what I want to explain is the relationship between these two common measures. Okay, this is actually a conversion factor. Okay, that 180 degrees is equal to 1 pi radians. Okay, so meaning yung isang straight angle, an angle that is exactly 180 degrees, this one is actually equal to 1 pi radians. Okay, so pag i-convert natin itong 180 degrees into radian measurement, yung equivalent niya is 1 pi radians. Okay, so kung 1 pi radians yung 180 degrees, how about yung 360? How about yung dalawang 180 degrees? Meaning, it will be just 2 times 1 pi radian. Or this full angle is actually equal to 2 pi radians. Okay, so more on that later as we convert angles. So before we proceed, okay, since the next things that we will be doing will be solving, okay, so you get a piece of paper for in writing the solution. So of course, ball pen and then your calculator. So yung calculator natin, kung meron kayo yung scientific calculator na FX 991, then get that. If wala, pwede kayong mag-download ng calculator sa Google app na FX 991, okay, sa Google Play Store, okay, so that meron kayong magamit na calculator. Okay, so pwede nyo ma-download yun sa inyong cellphone, okay, and use it in solving. Okay. So for the conversion of angles, so for example, convert 90 degrees to radian measurement. So for the solution, so ito yung gagamitin natin na conversion factor, yung binanggit natin kanina, na 1 pi radian equals 180 degrees. Okay? So yung 90 degrees, okay, i-multiply natin yung ating conversion factor. Now, bakit nandito sa ilalim yung 180 degrees at yung sa ibabaw yung 1 pi rad? Okay? Ginawa natin yan sa conversion factor because, okay, gusto nating ma-cancel out itong degrees. Okay? Wala yung degrees na yan, yung matira na lang na unit will be radian. Since we need to convert from degrees to radian measurement. So ito na yung nangyari. 90 degrees na given times the conversion factor will be equal to, okay, so mawala yung degrees, okay, then 90 over 180, this is just equal to 1 over 2, okay, then matitira yung 1 pi rad sa ibabaw, which gives us 1 times 1 pi will be pi all over 2 radians. So this will be our answer. Okay? So pi over 2 radians is equal to 90 degrees. If we try to check, kanina sinabi natin na 180 degrees is actually equal to 1 pi. So pag itong pi dito, sinubstitute natin yung 180 degrees. 180 degrees divided by 2, automatic it will be equal to 90 degrees. So tama itong pi over 2 na nasolve natin. Okay? For our next example, so example number 2, convert 68 degrees, 35 minutes, and 45 seconds to radian measurement. So kanina yung problem natin is medyo simpler lang yun compared dito sa pangalawang problem. Okay? For the solution, okay, so we'll be using 3 conversion factors. But these conversion factors, I'm sure meron na kayong idea. Okay? So you'll just have to think about or relate this one to a clock. Okay? Yung clock natin or yung orasan natin, okay? Yung isang minuto sa isang orasan is equal to 60 seconds. Okay? Now for 1 degree, there are 60 minutes. Okay? And of course, yung ating nabanggit na nga kanina na conversion factor
for radian and degree, we have 1 pi radian is equal to 180 degrees. Now, how will we use this one? Okay, so just think about degree. In this case, kung orasan yung ating gagamitin as reference, so yung degree, isipin natin na oras. Okay? In 1 degree, 60 minutes. In 1 minute, 60 seconds. Okay? Now, so itong 35 minutes na binanggit natin kanina, kung i-convert natin ito into degree measurement, okay? So, gamitin natin yung conversion factor natin that in 1 degree, 60 minutes. So, mapapansin na naman natin dito na yung 60 minutes na conversion factor natin, yung minutes nasa ilalim, okay, yung degree nasa ibabaw. For us to cancel out itong minutes, okay, na unit. So, makakancel out yan. Then, 35 times 1 divided by 60, okay, using your calculator, lalabas ito. Okay? So, kung hawak niyo yung calculator niyo ngayon, you can check this one, that 35 divided by 60 is actually equal to 0.5833333, okay, degrees. Now, for the second one, so itong 35 minutes na convert na natin into degrees, ito namang 45 seconds. Now, 45 seconds, meron tayong dalawang conversion factor na gagamitin. Yung 1 minute is to 60 seconds. So, makakancel natin yung seconds natin dito. Then, itong 1 degree, 60 minutes. So, by doing that, makakancel natin yung seconds. And then, makakancel natin yung minute. Yung matitira na lang na unit will be yung degrees. So, 45 times 1 times 1 divided by 60, then divided by 60 pa ulit. So, makukuha natin tong value that 45 seconds is equal to 0.0125 degrees. Now, combining these degree measurements, this one, at itong 68 degrees dito, okay, we'll get that 68 degrees, 35 minutes, 45 seconds is just equal to the 68 degrees, yung na-solve natin kanina, at ito naman. Okay. Pag in-add natin, tinotal natin to lahat, we have 68.59583333 degrees. Now, this is not yet the final answer since we are tasked to get or to convert this value to radians. Since ito naka-degrees pa, okay, convert muna natin. So, by using this conversion factor, so mapapansin na naman natin yung 180 degrees na sa ilalim. So, magka-cancel out itong degrees. So, 68.59 times 1 pi divided by 180, ito yung makukuha natin. Okay? So, yan. 0.381088 pi radians. Now, kung mapapansin nyo, kinuha natin yung 6 na numbers since meron din tayong 6 na numbers dito sa ibabaw. So, for example number 3, so ito naman, we convert radians to degree measurement. So, convert pi over 3 radians to degree measurement. Okay? So, for the solution, so again, we use this AC conversion factor. Okay? So, yung given natin na pi over 3 radian, okay, we just multiply this one to our conversion factor. Now, mapapansin nyo dito na nag-iba yung positioning ng ating conversion factor. Kanina, when it is from degree to radian, yung 180 degrees na sa ilalim. But right now, since it is from radians to degree measurement, yung radian natin nasa ilalim. Okay? Now again, ginawa natin yan since kailangan natin makancel out yung radian na unit para matira na lang yung degrees. Okay? So by doing that, yung pi sa ibabaw at saka sa ilalim, ng numerator at denominator magka-cancel out. So that is equal to 1. At yung radian sa numerator at radian sa denominator magka-cancel out. So you are now left with 180 degrees divided by 3. Okay? Times 1. Or 180 degrees divided by 3. So that is equal to 60 degrees. Now again, to check this one, pag pinalitan natin yung pi ng 180 degrees, since that is the conversion factor, 180 degrees divided by 3 is just equal to 60 degrees. So alam natin that ito yung sagot, or sakto yung ating nakuha na answer. Okay? Now, so this will be our example number 4. Sorry for the one. So, example number 4 na ito. Convert 0.47623 radians to degree measurement. So, ito medyo komplikado na to kasi nga, okay, 5 decimal places yung given in radian measurement. But still the same, okay, same application. Yung given natin, multiply lang natin ng conversion factor natin. Same, nasa ilalim pa rin yung radian na conversion factor. Magka-cancel out yan, yung rad. Then, 0.47623, gamit yung calcio ninyo, ito, multiply natin sa 180 divided by pi. Okay? So, yung matitira na unit na lang natin will be in degrees. So, again, meron tayong 5 decimal places since 5 decimal places din yung nasa ating given, okay, for the degree of accuracy. Okay, now, so after we have already solved for conversion from degree to radian, then radian to degree, we'll now start solving right triangles. So, since ito naman talaga yung first lesson natin, or the first major branch ng plane trigonometry. So, there are things to remember in solving right triangles. So, first and foremost, the sum of angle measurements within a triangle is equal to 180 degrees. So, kahit anong klaseng triangle to, whether it's a right triangle or an oblique triangle, the sum of the internal angles, yung angle na nasa loob, okay, ng triangle is equal to 180 degrees of. In this case, sa triangle na to, theta plus the right angle plus beta equals 180 degrees. So, theta plus yung right angle na 90 degrees plus yung beta, the total will be equal to 180 degrees. Okay, that is the first thing to remember when solving right triangles. Second is the hypotenuse. Okay, so the hypotenuse is the longest side. Basically, the longest side of the right triangle. So, in this case, yung hypotenuse natin is this one. Yung pinakamahaba na side ng ating triangle. Okay? The next one is the adjacent side with respect to the angle. Isa naman is we call the opposite side with respect to the angle. Pag sinabi namang opposite, kung adjacent is katabi, yung opposite naman is, okay, atbang. Okay? Opposite, ano ba yung katapat? Okay? Katapat na side. Again, with respect to the angle. Now, very important tong binanggit dito, with respect to the angle. Okay? Adjacent side with respect to the angle, opposite side with respect to the angle. For example, we consider this angle theta. Okay? So, alam na natin that this is the hypotenuse. So, yung hindi na lang natin alam, is T adjacent to theta or is it opposite? Is M adjacent to theta or is it opposite? So, in this case, since if we consider angle theta, okay, yung katapat niya na side, atbang niya na side, is itong side na M. Okay? Atbang. Well, yung katabi niya na side, since dalawa lang to na side, it's either ito or ito. But since ito, we already determined this one to be the hypotenuse of our triangle. So, walang ibang adjacent side, kundi ito lang. Okay? So, this T. Okay? T is the adjacent side with respect to angle theta. And M is the opposite side with respect to angle theta. But if we consider beta, okay, ito naman, itong angle na to, yung adjacent side ng beta, yung katabi niya, so, dalawa lang, this one na side or this one. Now, since this one is already the hypotenuse, so wala nang pag-asa yan na maging adjacent. So, automatic, itong M will be our adjacent side. Katabi na side ni angle beta. Yung opposite side naman ng angle beta will be itong side T. Katapat. Okay? So yan. And lastly, nothing to remember, the Pythagorean theorem. Okay? It is used to find a missing side of a right triangle when given two sides. Okay? So kung pinahanap sa iyo yung isang side, given may value itong t at saka m, masosolve natin to. Given ka ng hypotenuse at itong m, masosolve natin yung t. So basically, yun yung ibig sabihin ng meaning nito. So ano ba yung Pythagorean theorem? So it states that the sum of the squares of the two legs of a right triangle is equal to the square of the longest side. So in equation form, it will look like this. So kung ito yung triangle natin in consideration, okay, the formula will be in the form t squared plus m squared is equal to s squared. Now, paano naging ganyan? Okay? Base dito sa binanggit kanina na Pythagorean theorem, sabi niya, the sum of the squares of the two legs of a right triangle. So, yung two legs na binabanggit niya dito is this m at saka itong t. Since this one is not a leg, this is the hypotenuse or the longest side. Okay? The sum of the squares of the two legs t and m is equal to the square of the longest side. So the square of the longest side, which is s. So kaya ganito yung nangyari sa formula for Pythagorean theorem. So those are basically the four things or the five things that we need to remember. So again, balikan natin. Okay, the sum ng angles within a triangle, right triangle is 180 degrees. The hypotenuse is the longest side. The adjacent side is yung katabi. Opposite side is atbang, okay, or katapat na side. Okay, again, very important kung anong angle yung pinagbabasehan natin. Okay? And then lastly, yung ating Pythagorean theorem. Okay? Now, there are 6 trigonometric functions of angles. Okay? So, ito yun. Kalista dito. Sine, cosine, tangent, cosecant, secant, cotangent. Now, these are yung mga abbreviations. Yan. Ito yung makikita natin sa calculator. Sin, cos, tan, cosecant, secant, cot. Okay? So, sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now, paano ba natin makukuha yung values nito? Okay, so, how will we solve or find the values of the 6 trigonometric functions that were mentioned a while ago? Okay, so given this triangle, so we have this given angle theta, the right angle, then these sides s, t, and m, where s is our hypotenuse. Okay, so if we will solve for sine theta, okay, sine theta is just equal to the opposite side with respect to the given angle over the hypotenuse. So in this case, our given angle is theta. Okay? So the opposite side to angle theta, yung atbang or katapat na side ni angle theta, is this side t divided by the hypotenuse. That is why it is equal to side t divided by side s. Okay, nasundan? Now, for cosine theta, okay, cosine theta with respect to this triangle is equal to the adjacent side with respect to angle theta divided by the hypotenuse. So, theta is here. So, yung katabi niya na side, di pwede yung s kasi ito yung hypotenuse, is the side m. Okay, so ito yung adjacent side divided by the hypotenuse. So, that is why it resulted to the side m divided by side s. Now, for tangent theta, okay, it is equal to the opposite side with respect to angle theta divided by the adjacent side. Again, with respect to angle theta. So it is opposite side t divided by adjacent side m. Okay? Kaya it is t divided by m. So, madalas nating maririnig ito, especially pag trigonometry. Okay? Ito yung may mnemonic, or para mas madali nating maalala, na so, ka, towa. Okay? So, meaning S sine opposite over hypotenuse. So, S, O, H, ka, C, A, H, cosine is adjacent over hypotenuse. Then, towa, tangent, T, O, A. Okay? Opposite over adjacent. Now, what about the remaining three trigonometric functions? Okay? The cosecant, okay, secant, and the cotangent. Now, for cosecant, it is just the hypotenuse over the opposite side. Okay? For secant, it is just hypotenuse over adjacent. For cotangent, adjacent over opposite. Na kung mapapansin ninyo, okay, kung titingnan nyo yung nasa kaliwa, okay, this is the sine theta. Dito, opposite over hypotenuse. Dito naman, hypotenuse over opposite. Kung dito, t over s, dito, s over t. So, parang in-interchange lang natin. Ang tawag dito is, we just took the reciprocal of the value of the sine of the angle. Okay, kung dito t over s, pag kunin natin yung cosecant theta, it is just s over t. Pag kunin naman natin yung secant, okay, it is just the reciprocal of the cosine theta. Kung m over s yung cosine theta, yung secant theta natin will be s divided by m. Okay? Kung kunin naman natin yung cotangent, kung tangent theta natin is t over m, mangyayari sa cotangent theta natin will be m over t. At kung dito, it's so, ka, towa, ito naman, cho, sha, kaw. Okay? Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. Okay? So, yan. So, that's how we get the trigonometric function values. Now, values since pwede kasi na yung s, m, at saka t may value. Okay? So, pag may value yan, substitute lang natin dito. Dito. Okay? So, here we have a challenge. So, sabi dito, you try. Determine the 6 trigonometric function values of angle beta and compare with the results for angle theta. So, this one, itong nasolve natin dito is actually the 6 trigonometric functions of angle theta. Okay? Now, for this challenge, okay, what if meron tayong this angle? We call this angle beta. Okay? Ano daw yung 6 trigonometric functions ng angle na to? Okay? And then you compare it with the results for the 6 trigonometric functions of angle theta. Okay? So you do that. Okay? Tingnan natin kung makukuha ninyo yung relationship between the two. Okay? Now, we have a sample problem here involving a right triangle. So, sabi dito, given the right triangle below, this one, solve for the value of h, the 6 trigonometric function values of angle theta, and also the value of theta and beta. Now, ito daw, hanapin daw natin yung value ng side h, the 6 trigonometric function values of angle theta, ano daw yung 6 trigonometric function values nito, the value, anong value din ng theta, and the value of beta. So, how do we solve this? Okay? First and foremost, so for solving the value of h, okay, we will be using yung binanggit natin kanina na thing to remember. We'll use the Pythagorean theorem, okay, to solve for the value of h. So, nabanggit natin kanina na pag given ka ng dalawang side, okay, in this case, 12 at saka 5, may missing na side, isa. Pwede natin gamitin yung Pythagorean theorem kapag yung given na triangle ay right triangle. Okay? So, in this case, the square of the two legs, 5 and 12. So, 5 squared plus 12 squared is equal to the square of the longest side, which is h, yung hinahanap natin. So, 5 squared plus 12 squared, that will be 25. Since 5 squared is 5 times 5, 12 squared is 12 times 12, so 144. So, 25 plus 144 is 169, equal to h squared. We take the square root of both sides, take the square root of 169, take the square root of h squared, okay? So, we'll have 13 units is equal to h, okay? So, we now solve the value of this side, determine the value of this side to be 13 units. Now, we can directly check our answer, okay? We said that h is the longest side. Kung compare natin yung value, since this is 13, makita natin that 13 is actually greater than the given sides, which are 5 and 12. Okay? So, by that, masasabi natin na kahit na, okay, hindi pa natin na-check, okay, this 13 is malamang, ito talaga yung answer since it is greater than the two given sides. Okay? Next, we solve for the 6 trigonometric functions of theta. Now, this is theta. So, ano din yung 6 trigonometric functions? So, una, gamitan natin ng SOHCAHTOA. Okay? So, for the sine theta, opposite over hypotenuse. Opposite ng theta na side is 5 over hypotenuse na 13. Okay? Yung cosine theta, ka, adjacent over hypotenuse. Adjacent side ng angle theta, yung katabi niya na side, is 12 over 13. Okay? Yung tangent naman ng angle theta is TOA, opposite over adjacent. So, kung ito yung angle theta, opposite, katapat niya is 5, adjacent niya is 12. Okay? So, 5 over 12. Now, taking the reciprocal of all these 3 trigonometric functions, so yung cosecant theta, baliktarin lang natin, 13 over 5. Yung secant theta, baliktarin lang natin yung cosine, so we have 13 over 12. And then yung cotangent theta, baliktarin lang natin yung tangent, it will be 12 over 5. You just take the reciprocal, or Chosha Cow. Okay? So these are the 6 trigonometric functions of angle theta. Okay. Now, what if we want to determine the value of angle theta? Ano ba yung, ilang degrees ba to? Itong angle na to. So to find that, we just get one trigonometric function. Okay. For example, we take the value of sine theta, which is equal to kanina 5 over 13. Now, to solve for the value of theta, we take the arc sine of both sides of the equation, or we take the inverse trigonometric function. Kung sine yan, arc sine yung kanyang inverse trigonometric function. So how do we do that? So we take the arc sine of sine theta, we take the arc sine of 5 over 13. Kung ano yung ginawa mo dito sa kaliwa, gawin mo din sa kanan to preserve the equality. Okay? So in this case, pag kinuha natin yung arc sine ng sine, this will just be cancelled out. Matitira yung angle na theta. And if we, kung gamitin natin yung calcu, okay, sa ibabaw ng sine button sa calculator, okay, kung hawak niyo yung calculator niyo ngayon, tingnan niyo sa ibabaw ng sine na button, may makikita kayo dyan na naka-yellow. Okay? The symbol arc sine. Okay? So meaning ng naka-yellow is ipipress nyo pa yung shift ng calculator, then press the sign button para lumabas ito sa inyong calculator. Okay, so arcsin, then open parenthesis, 5 divided by 13, lalabas yung sagot na theta is equal to 22.62 degrees. Okay? So ito palang angle na to is 22.62 degrees. How about angle beta? Ano yung value ng angle beta? Okay? Now, by the way, before we proceed to solving beta, okay, you can also try, okay? Kanina ginamit natin arc sine, okay? But what if gamitin mo yung value ng cosine theta, okay? But instead of using arc sine, gagamitin mo arc cosine or this, okay, symbol. So again, kung ang arc sine nasa ibabaw ng sine button ng calcu, ito naman nasa ibabaw to ng cosine button ng calculator. Okay? Yung tangent theta naman, kung gagamitin mo to, instead of using arc sine, gamitin mo arc tangent. Okay? And then proceed. Tingnan natin kung makukuha mo pa rin ba yung same result na theta is 22.62 degrees. Okay? Now, since na-solve na natin yung 22.62 degrees, okay, if we add all the angles in a triangle, sabi natin kanina sa thing to remember, the sum is 180. Pag in-add natin itong theta, itong 90 degree angle, at itong beta, equal sa 180. So, since nakuha na natin yung theta, 22.62, beta, hindi pa natin alam, the 90 degrees equals 180. Kung ilipat natin to sa kabila, magiging negative. Ito naman, pag ilipat sa kabila, magiging negative. Maiiwan yung beta. Okay? At pag isolve mo to, na 180 minus 22.62 minus 90, lalabas yung sagot that beta is 67.38 degrees. Okay? Now, there's another challenge here. Here's another way to solve for the value of beta. So, merong ibang paraan para masolve yung beta. Based on our previous discussions na kung ano yan, can you find this other way? Okay? Meron ka bang naiisip na paraan paano makuha yung 67.38 na hindi gagamitin itong pamamaraan na ito? Okay? So again, you base it on the previous discussions. Okay? Now, the summary of answers. So yung H, nakuha natin kanina, 13 units through Pythagorean theorem. Yung 6 trigonometric functions, nakuha natin gamit yung SOHCAHTOA at saka Shakaw. Then yung theta nakuha natin gamit yung inverse trigonometric function, whether it's arc cosine, arc sine, arc tangent. At yung beta, which is equal to 67.38 degrees. Okay? So if you have questions relating to this video, you may write it on the comments below. Okay? If wala naman, okay, I have prepared an assignment related to this lesson, okay, that I will be posting on our Google Classroom. So you may also check that out. It is worth 20 points, okay, and it is an application of the things that we have discussed here in this slides. Okay? So, meaning kung hindi nyo naintindihan or hindi nyo naintindihan itong diniscuss natin dito, mahirapan din kayo dun sa ating ginawang assignment. But if you understood the topics that we have discussed here, hindi kayo mahirapan when answering that particular assignment. So, pwede din kayong mag-collaborate with your classmates in answering, okay, through social media. Kasi nga, hindi tayo pwedeng magkita-kita ngayon since quarantine. Okay? So, with that, I leave you with this first lesson, and I'll be giving additional materials for you to solve and for you to apply the lessons that you have learned in this particular discussion. Okay? So, see you on the next lecture video. Okay, good morning and welcome to another session on word problems in trigonometry. Okay, the intended learning outcome for this session are as follows. At the end of this lesson, the student shall be able to understand why we need to learn trigonometry, okay, especially in the context of the Bachelor of Science in Marine Transportation. Second is to solve basic problems relating to trigonometry. Okay, so solve muna tayo ng mga basic bago tayo pupunta dun sa complex problems. Okay, and then lastly, to solve problems related to course and bearing. Okay, so without further ado, let's start. First is, why do we need to learn trigonometry, especially in your particular chosen profession? Okay, so in navigation, there are three terms that is related to trigo. These are what we call a course, a bearing, and a heading. Okay, so by definition, a course is a planned route. Okay, so if you look at this picture here, this red line, okay, itong path na to, is actually the course, the planned route of a particular vessel. Okay, now the second term is what we call the bearing. So bearing is the direction from your location to any distant point given in degrees from north. So unsa man ni? Very complicated. Okay? Itong definition. Bearing is the direction from your location. So for example, this is your location at point B. Okay? To any distant point. Okay? So if this is your location and this is the distant point D. Okay? Then we connect these 2 points. Okay? And then measure the degrees from north. So lalagay tayo ng linya dito. That is north. Okay? And then we create an angle, okay, from this north papunta dito sa line na to. And this is now our bearing. The direction from your location to any distant point given in degrees from north. Okay? So lastly is the heading. So heading is the direction that your ship is pointing. Or kadalasan, yung iniisip natin, yung heading is directed, for example, from C to D. So yung direction ng heading mo is pointing to point D, but this is not necessarily the case, okay? Especially when there is wind or current. So mapapansin nyo dito yung heading niya is tabingi. This is the course, but the heading is tabingi because there is this wind or current acting on our vessel. So kahit na tabingi yung heading natin, because of this wind or current that pushes our vessel, so darating pa rin tayo dito sa certain destination natin, which is at point D. Okay? So, those are the things that are related to trigonometry. Kaya tayo nagsosolve previously ng mga angles. So, makikita nyo dito 30 degrees. Okay? Makikita nyo dito that we have triangles involved. Okay? So, dito lang, yung involved na triangle dito is oblique triangle, which is our next lesson. So before we solve problems, basic problems involving trigonometry, we have few terms that we need to consider. Okay? The first one is what we call the angle of elevation. So the angle of elevation of an object, as seen by an observer, is the angle between the horizontal and the line from the object to the observer's eye, also known as line of sight. So again, medyo komplikado yung definition. Tingnan natin through a certain illustration para mas makita natin. Ano ba yung ibig sabihin nito? Okay? So, for example, we have this man. Tawagin natin siyang Timmy. Okay? This is our observer. Okay? And then, he observes a certain object. Okay? This airplane. Okay? So, sabi dito sa definition, the angle of elevation of an object, this object, as seen by an observer, si Timmy, is the angle between the horizontal. So, gagawa tayo ng horizontal line on level sa kanyang eyesight. Okay? Horizontal, and the line from the object to the observer's eye. Line from the object to the observer's eye, also known as the line of sight. Okay? So, the angle between these two, okay, from the horizontal papunta dito sa line of sight, yan, this alpha, this is what we call our angle of elevation. Okay? Now, the next term that we need to consider is the angle of depression. Okay? So if the object is below the level of the observer, then the angle between the horizontal and the observer's line of sight is called the angle of depression. So in this particular case, meron tayong building. Sa ibabaw ng building, nandun nakatayo si Timmy. Okay? And then, dun sa ilalim ng building, on one of the roads, nandun si Cynthia naman. Itong babaeng to. Okay? Now, the angle of depression daw is from the observer, which is si Timmy, to the object, which is si Cynthia, and this is our line of sight. And we connect this to an angle, and this is now our angle of depression, represented by the Greek letter beta. Okay? So, angle of elevation and angle of depression. Okay? So, now that we have already pointed out the difference between an angle of elevation and angle of depression, let's start by solving one simple problem muna. Okay? So, for our first example, okay, we have this example. If the height of a tree is 8 meters and the length of its shadow is 6 meters, find the angle of elevation of the sun with respect to the ground. Okay? So, in these kinds of problems, especially in trigonometry, very important na alam natin paano mag-drawing. So, dito lang sa PowerPoint, since hindi tayo nagsusulat, okay, hindi ko mapakita sa inyo paano i-drawing. Okay? But, I'll just illustrate it through this drawing. Okay? So, if the height of a tree is 8 meters, ito yung kahoy natin, height doon yan is 8 meters. And the length of its shadow, yung haba ng anino, is 6 meters. Find the angle of elevation of the sun with respect to the ground. So, ano din yung angle of elevation? This angle, so since this is our horizontal, this is our line of sight to the sun, ano din yung angle of elevation natin dito? Okay? So, solution, let theta be the angle of elevation. So, this one, ito yung theta. Now, review of our previous lesson. The height of the tree is blank with respect to angle theta. Itong height na to, or itong side ng triangle na to, okay, what is its relation to angle theta? At bang ba siya? Hypotenuse ba siya sa triangle or adjacent? Okay? So if you have understood our previous lesson, the answer should be, it's the opposite side. Since this is theta, at bang niya, is it yung 8 meters. Second one is, the shadow of the tree is blank with respect to angle theta. Itong shadow na to, itong 6 meters na to, ano yung relationship niya with regards to this angle? Since meron na tayong opposite, dalawa na lang yung pagpipilian natin. It's either it's the adjacent side or the hypotenuse. But in this case, again, if you understood the previous lesson, this is the adjacent side. Or sa Bisaya pa, katapad. Okay? So, dual ang katapad ni theta. This side or this side. In this case, itong side na to is the hypotenuse. Okay? This is the longest side of our triangle. So, automatic, this one is our adjacent side. Okay? Now that we have determined that yung 8 meters pala, itong side na to is opposite, at itong 6 meters pala is adjacent, we can now solve this angle theta. Okay? We have opposite and adjacent. So, katawa. So, ang gagamitin natin dito will be tangent. Theta, opposite over adjacent. Now, tangent theta is equal to, yung opposite side is 8, adjacent side is 6. So, yan. Then we take the arctangent or the inverse trigonometric function of tangent on both sides. So, arctangent, okay, this cancels out, leaving theta on the left side of the equation. And theta, kung i-calculate nyo to sa calculator, will lead you to this particular value, 53.13 degrees. And this is now our angle of elevation. Okay? Ang katapat ni theta, it's either this side or this side. In this case, itong side na to is the hypotenuse. Okay? This is the longest side of our triangle. So automatic, this one is our adjacent side. Okay? So now that we have determined na yung 8 meters pala is opposite, yung 6 meters pala, now that we have determined that yung 8 meters pala, itong side na to is opposite, at itong 6 meters pala is adjacent, we can now solve this angle theta. Okay? We have opposite and adjacent. So, katawa. So, ang gagamitin natin dito will be tangent. Theta, opposite over adjacent. Now, tangent theta is equal to, yung opposite side is 8, adjacent side is 6. So, yan. Then we take the arctangent or the inverse trigonometric function of tangent on both sides. So, arctangent, okay, this cancels out, leaving theta on the left side of the equation. And theta, kung i-calculate nyo to sa calculator, will lead you to this particular value, 53.13 degrees. And this is now our angle of elevation. Okay? For our next example, so kung kanina it's angle of elevation, this time we'll solve a problem involving angle of depression. So here's our problem. Timmy is standing on the edge of a hill when a maritime ship passes by. Okay? Timmy is 75 meters above the ground, while the angle of depression from his position to the ship is 30 degrees. How far is the ship from the bottom of the hill? And how long is the line of sight? So again, para mas makita natin anong ibig sabihin ng problem na to, it's very important na kaya nating i-drawing kung ano yung ibig sabihin ng problem. Okay? So here we have, sabi dito, Timmy is standing on the edge of a hill. So kanina, nasa ibabaw ng building si Timmy. Ngayon naman, nandito na naman siya sa edge ng hill. So dito, okay? So buwis buhay itong taong to. Okay? So andito sa ibabaw si Timmy. Okay? When a maritime ship passes by. So we have this maritime ship, and then it passes by. So again, Timmy is standing on the edge of a hill when a maritime ship passes by. Now, Timmy is 75 meters above the ground. Okay? So from the ground daw, papunta dyan sa kinatatayuan ni Timmy, it's 75 meters. While the angle of depression from his position to the ship is 30 degrees. So from his position to the ship, okay, the angle of depression, ito, the angle of depression is 30 degrees. So again, yung kanina, from the line of sight, gawa tayo ng horizontal line, then ito, connect natin papunta dun sa object, and then we create our angle of depression. Now, how far is the ship from the bottom of the hill? So, gaano do kalayo itong ship na to to the bottom of the hill? So, this one. So, let's represent it by the small letter C. Then, second is, how long is the line of sight? Gaano do kahaba itong linya na to, yung line of sight, connecting the eye of the observer to the object. So, let's represent it with a small letter J. Okay? So, before we proceed solving this problem, kailangan natin maintindihan that this triangle, ito, is actually a, okay, right triangle. Since may right angle siya dito. And then, next one is, itong linya na to is a horizontal line. This same line here is also a horizontal line. This is the line of sight. So, horizontal line ka, may linya, 30 degrees. Horizontal line ka, meaning, ito palang angle na to is also 30 degrees. And now that we have determined that this is a right triangle, and this is also 30 degrees, we can now solve this triangle ito. Okay? So, let's proceed. So, yan. This 30 degrees, 75 meters, yung C at yung J. So, first, for our solution, let's C be the distance from the ship to the bottom of the hill, and J be the length of the line of sight. Ito. Okay? Now, J is the blank. Ano ba to? Ng triangle. Okay? Based on our previous lessons, you should have answered, it's the hypotenuse. Okay? Next, yung 75 meters. 75 meters is blank of the given angle 30 degrees. So, itong 75 meters, yung relationship niya sa 30 degrees, it is the opposite side. Okay? And then lastly, C is, kung hypotenuse yan, opposite, automatic this will be the adjacent side. And having determined this one, we are now ready to solve this problem. So una, kailangan yung piliin natin na trigonometric function, yung involve yung dalawang values, yung 75 meters at yung 30 degrees. Okay? So yung pinili natin for this solution is, ginamitan natin ng tangent 30 degrees. Okay? Tangent is opposite over adjacent. So, 75 over C. Now, cross-multiplying, yung C pupunta dito sa kabila, yung tangent 30 pupunta sa ilalim ng 75 degrees. So, ito yung mangyayari. And then after that, we calculate this using our calculator, we will get the answer 129.9 meters. So, this is now the distance from the ship to the bottom of the hill. Okay? The next one is, what is the length of the line of sight? So nakuha na natin yung C using tangent, yung trigonometric function na tangent. How will we solve for J? Okay? Now, hindi ko na i-solve yan. You try. Solve for the length of the line of sight. Ito, using the following. Pwede mong gamitin Pythagorean theorem, sine, and cosine. Notice that you will arrive on the same answer. Comment down your answer below. Kung ano ba yung value ng J, okay? Dito sa ating YouTube channel. Now, kung mapapansin nyo class, dun sa previous natin na lessons, okay, pinakuha ko sa inyo yung 6 na trigonometric function values. But kung napapansin nyo dito sa pagsosolve natin, okay, pipili ka lang ng isa. Ano ba yung pinaka-applicable? At yung pinaka-applicable ng trigonometric function is the one involving 2 given values. Okay? Ano yung trigonometric function na pwede mong magamit na involve yung dalawang given? Okay? At isang unknown. Pag nahanap mo yun, then you can solve that unknown value. Okay? For our third example, a statue is situated on top of a building. The height of the building is 100 meters. Cynthia is standing at a spot where the angle of elevation to the top of the building is 45 degrees, while the angle of elevation to the top of the statue is 60 degrees. Determine the height of the statue. Okay? So again, to start with the solution, so we draw this particular problem. Okay? So sabi dito, a statue is situated on top of a building. So we have a building and then there is a statue on top. Okay? The height of the building is 100 meters. So yung height pala ng building na to is 100 meters. Now, Cynthia, so yung character natin na pinangalanan, is standing at a spot, okay, where the angle of elevation to the top of the building is 45 degrees. So andito daw si Cynthia sa spot na to, wherein the angle of elevation to the top of the building, so dito na spot, okay, is 45 degrees, okay? While the angle of elevation to the top of the statue, so same spot, pero ngayon nakatingin siya dito sa top of the statue, the angle of elevation is 60 degrees. Now, determine the height of the statue. Gaano daw ka haba itong statue na to or kataas itong statue na to? Okay, so that's our problem. Now, to start the solution, okay, so we let h be the height of the statue, okay, and t be the distance of Cynthia to the base of the building. So itong distance na to, from the base of the building papunta kay Cynthia, we let that as the variable t. Bakit kailangan nating mag-let ng variable dito? Okay? Bakit hindi na lang h? Kasi yun lang yung hinahanap. Okay? The premise here is that itong side na to, okay, if you try to look at it, itong side na to is common to this small triangle, okay, and to the big triangle. At malaki yung papel nito na gagamitin mamaya on our solution. Okay? Para tong domino effect. Kailangan mo munang daanan itong t, makuha mo muna yung t bago natin makuha yung h. Okay? Mamaya. So to continue our solution. Okay. So tanggalin muna natin yung big triangle. Focus muna tayo on this smaller triangle. Now kung naalala nyo sa previous video, sabi natin doon or in-emphasize natin doon na pag meron kang dalawang given sa triangle at meron kang isang unknown, maghanap ka ng relationship between these three, okay, these three tawag nito, items, okay, yung 45 degrees, yung 100 meters, at saka itong side na t. Now this angle, yung relationship niya sa 100 meters, kung titingnan ninyo, okay, yan, ano ba yung relationship ng 100 meters sa 45? Then, ano ba yung relationship ng t sa 45. Now, hindi ko nasasagutan yan. I want you to think about it, okay? And then complete this particular solution, okay? Now, after determining ano ba yung relationship ng 100 meters sa 45 degrees at ano yung relationship ng t sa 45 degrees, we proceed with our solution, okay? So, ito, you try. What trigonometric function will we use here? Anong trigonometric function? Sa anim na trigonometric function values, ano yung pinaka-applicable? Okay? Now, for the solution, so again, you fill this up. Anong trigonometric function? Okay? Na yung numerator magiging 100 meters, tapos yung denominator is over t. Okay? And of course, nangyari dito, we cross-multiply. Yung t, pupunta dito sa ibabaw. Ito naman, okay, pupunta dito sa ilalim. Now, if tama yung inyong ginamit na trigonometric function dito, we will arrive on the same answer of 100 meters. Meaning, yung distansya ni Cynthia pala from the base of the building at yung height ng building is the same. Okay? So, sakto lang din kasi kung titingnan mo dito, this is 90 degrees. Okay? This is 45. Sabi natin last time na yung sum of internal angles within a triangle is 180. So, meron kang 90, meron kang 45. So, ano yung kulang para maging 180? So, it's also the same. 45 degrees din dito. Kaya, kung yung 45 degrees dito, yung katapat niya is 100 meters. If this is also 45 degrees here, yung katapat din yan will be 100 meters. Now, going back sa problem, hindi ito yung hinahanap. Hinahanap natin dito is the value of the height of this statue. Sabi natin kanina, domino effect, na pag na-solve natin yung t, makukuha natin yung h. So, paano natin gagawin yan? Okay? So, kung nagamit na natin itong smaller triangle, balikan natin yung bigger triangle. Okay? Tanggalin natin yan, and ibalik natin yung bigger triangle. Okay? Yung angle of elevation natin, from 45 magiging 60 degrees. Na kung titingnan natin dito, itong bigger triangle, okay? Itong side na to, yung 100 meters plus yung height ng statue, kaano-ano yan ng 60 degrees? And then the same, itong t, kaano-ano yan ng 60 degrees? Pag nakuha nyo yan, we proceed with our, okay, solution. Okay? So, sagutan nyo yan, sagutan nyo din dito. And then, so for the solution, so ano yung gagamitin natin na trigonometric function? Wherein the numerator will become 100 plus h all over t. Okay? Yan, so substitute natin yung nakuha natin ng value ng t na 100 kanina. Okay, then we cross multiply yung 100 dito sa kabila. Okay? So 100 times yung trigonometric function of 60 degrees, ano yung pinaka-applicable dito? Is equal to 100 plus h. Then ilipat natin sa kabila, magiging negative. Okay? And that will give us the answer. Kung sakto yung pinili nyo or na sakto yung decisioning nyo kung ano yung trigonometric function na gagamitin, we will arrive on the same answer. That the height of this particular statue is actually 73.21 meters. Kung mapapansin nyo class, parang imposible naman yata na 100 meters yung building tapos 73.21 meters yung height. So these are actually arbitrary values na niya na sinele ko. But the point here is that ganun yung proseso ng pag-solve for these kinds of problem. Na parang meron tayong domino effect na nakita. Okay? So we have solved H by finding the common side ng smaller at bigger triangle which is T. Okay? So that is, so kung mapapansin nyo, yes, this is a level up. At kung napansin nyo, hindi ko ni-reveal yung mga kailangan nyong gamitin. Okay? Because it's important here na ma-establish na natin or mapasa na natin yung skill sa inyo. Yung decisioning kung opposite side ba to, adjacent side ba to, hypotenuse pa. Kung ano yung trigonometric function na gagamitin. Okay? Now, ito na. For our fourth example, so ito na yung gusto ko talagang or gusto natin na marating na topic which is about course and bearing. So kung naalala ninyo on the first part of this video, okay, sinabi natin na bakit natin kailangan matutunan yung trigonometry. Ano yung relationship nito with regards to the profession that you have chosen. Okay? So in this particular example, sabi dito, a private yacht sails for 1.3 hours at 5 knots on a bearing of 40 degrees. Then it turns and continues another 1.5 hours at the same speed, but on a bearing of 130 degrees. At the end of this time, how far is the yacht from its starting point? Now, meron tayong note dito. In case na hindi nyo pa na pag-aralan ito or na-discuss ito, 1 knot or the unit knot means nautical miles per hour. Okay? Now, how do we solve this problem? So again, magagamit natin yung definition ng bearing kanina or dun sa previous video. Okay? So we have a yacht. Okay, sabi sa problem, a private yacht sails for 1.3 hours at a speed of 5 knots. Okay? On a bearing of 40 degrees. So, to establish this bearing, so again, gawa tayo ng linya. Okay? So, kung naalala nyo yung compass glass, kung cross yan, yung north nasa ibabaw. North, then west, then south, then east. So, yung north nasa ibabaw. So, same lang din itong linya na to. This is the north line, okay, para ma-establish natin yung bearing. Kasi yung bearing is measured from north. Okay? So, from north, measure tayo dyan ng 40 degrees. So, yan. So, this is the line, yung direction, okay, or the course na kanyang tatahakin. And this is the bearing na 40 degrees. Okay? So, sa bearing na daw na to na 40 degrees, okay, nag-travel daw siya ng 1.3 hours at 5 knots. Okay? So, this yacht travels 1.3 hours in 5 knots. Again, nautical miles per hour. So, dito magka-cancel yung hour. 1.3 times 5, that will result into 6.5 nautical miles na lang yung unit. So, this is, malalaman natin that this distance, yung travel niya is 6.5 nautical miles. Now, after reaching that point, it turns, lumiko, and continues another 1.5 hours at the same speed. So, at the same speed na 5 knots. Pero yung bearing is already 130 degrees. Again, gawa tayo ng north line dito. And then this direction, okay, measure tayo ng 130 degrees. So, from north line, yan. So, mapapansin nyo dito, naglagay tayo ng linya dito since this line, perpendicular, this is 90 degrees. Since 130 degrees yung bearing natin, lalagpas siya ng, so 130 minus 90, lalagpas siya ng 40 degrees. Okay? To have this particular direction, on this particular direction. So, nag-travel siya dyan, 1.5 hours at the same speed of 5 knots. So, yung nakuha niya na distance, or na-travel niya na distance, cancel yung hour pa rin, 1.5 times 5, 7.5 nautical miles. So, ito palang distance na to, okay, is 7.5 nautical miles. Now, at the end of this time, 1.3 hours, 1.5 hours, how far is the yacht from its starting point? Gaano do kalayo itong position na to doon sa kanyang original position? So, let P be the distance between the yacht from its starting point. So, this distance, okay, gaano do kalayo itong P? How will we solve for P? So, now that we have already drawn the equivalent of this particular problem, we will now be ready to solve this problem. Okay. Now, for the solution, tanggalin muna natin yung di natin kailangan to solve this problem. Let us first establish if this is a right triangle or not. Okay? So, right triangle ba talaga itong nabuo natin? Para maging applicable yung mga natutunan natin ng mga formulas. So, to determine whether this is a right triangle or not, tanggalin muna natin yung hindi natin kailangan sa drawing. Okay? Tanggalin natin yan. So, let's focus our attention on this particular. So, nag-extend tayo dito. Okay? So, kung babalikan natin yung discussion natin about angles and measurement, okay? We learned there, kung babalikan nyo yun, na yung straight line, pag nag-measure ka ng angle from this point, papunta dito, okay? It is actually equal to 180 degrees. Okay? So, meaning, if this particular angle is 130, kung didiretso ka is 180, so ano yung value nito? Okay, so this is actually an angle. Tawagin natin yung beta. This beta is actually 180 minus 130 degrees, which give us the value of 50 degrees. Meaning, itong beta pala na to is 50 degrees. Now, this angle, let's call it angle gamma. Okay, kung titingnan mo naman to, okay, this line is vertical. This line is also vertical. Itong vertical line na to, okay, may linya tayo dito. Na-measure natin 40 degrees. Same line, may vertical line din tayo dito. So it follows this angle is also 40 degrees. Meaning, itong gamma natin dyan is 40 degrees. Now since beta plus gamma, pag i-add natin yan, we'll have a 90 degree angle. Therefore, this triangle na nabuo natin is actually a right triangle. So, ano bang purpose na? Bakit natin kailangan i-establish? Because yung mga formulas na natutunan natin, yung mga trigonometric function values, yung Pythagorean theorem, is only applicable to this particular triangle. Okay? Now, how do you find P? Okay? Nakuha na natin 90 degree right triangle na ito. How do we find P? Okay? Now, let's say this is angle theta. Yan. Itong angle na to. Now, this angle theta, alam natin that na-travel niya from the origin to this particular point is 6.5 nautical miles. Papunta dito sa kabila is 7.5 nautical miles. So, kung may angle tayo dito, okay, 7.5 nautical miles is kaano-ano ng theta? Is it opposite, adjacent, or hypotenuse? How about 6.5 nautical miles? Kaano-ano yan ng theta? Okay? So, I leave you to answer that. Okay? But here, sabi natin, gagamitan natin siya ng tangent. So, kayo nang bahala mag-understand paano naging 7.5 over 6.5 ito. Now, since establish natin to, we take the inverse, okay, trigonometric function on both sides, magka-cancel yung tangent theta. At kung i-calculate natin to sa calculator, we will arrive on the answer that theta is actually equal to 49.09 degrees. Now, bakit kailangan natin isolve tong theta? Okay? Bakit kailangan natin isolve ito? Dahil magagamit natin yan, okay, by using this particular trigonometric function, sin theta. Sin theta is equal to, okay, the opposite over the hypotenuse. Opposite ng theta is 7.5. Hypotenuse ng triangle is P. So by cross-multiplying this one, yung P pupunta sa ibabaw, ito namang sin theta pupunta sa ilalim ng 7.5. So ito na yung magre-resulta. So sinubstitute natin yung value ng theta na nasolve natin kanina. Then, pag i-input nyo sa calculator, we will arrive on this particular answer. That P, the distance from the origin to the final point, okay, is actually 9.92 nautical miles. Okay, so there you have it, an application of trigonometry to your chosen profession, which is bakit may angles, bakit may nautical miles, okay, bakit may term na knots, okay. Those things is actually related to the marine transportation. Okay? Napansin niyo from a very basic example to nag-i-increase in level of difficulty. But again, our intent here is to really establish yung analysis and how you will be able to decide what type or what trigonometric function will you use to solve the problems. Okay? Okay. If you find this video helpful, please leave it a thumbs up. And if you're not subscribed yet to this channel, subscribe. And I'll see you on the next video. Good morning and welcome to another video on oblique triangles. So the intended learning outcome for this session are as follows. At the end of this lesson, the student shall be able to differentiate an oblique triangle from a right triangle. Next is know what are the laws, law of sines and law of cosines. Next is understand the utilization of the law of sines and the law of cosines. And lastly, to solve problems involving oblique triangles. And here are our references. Let's start. So first, what is the difference between an oblique triangle versus the right triangle na sinolve natin last time? So sabi dito sa definition, an oblique triangle is a triangle with no right angle. So wala tayong makikitang right angle sa triangle na to. At the same time, an oblique triangle has either 3 acute angles or 1 obtuse angle and 2 acute angles. So ano ba yung itsura nito? Kung ito yung ating right triangle last time, we have a right angle. Sa ating oblique triangle naman, wala tayong makikitang ganito. It's either all angles are less than 90 degrees, yan yung sinasabi dito na we have 3 acute angles na triangle, or we have one obtuse angle greater than 90 degrees, and the other remaining angles ng ating triangle are acute angles. And these two triangles, this characterizes our oblique triangles. Next, things to remember when dealing with oblique triangles. So first is the Pythagorean theorem, yung SOHCAHTOA and yung Shoshakou na pinag-aralan natin last time, are not applicable to oblique triangles. So instead, we use the law of sines and law of cosines for oblique triangles. So isantabi muna natin yung napag-aralan natin ng mga formulas last time, and we focus on these two equations to solve these kinds of triangles. So kailangan ma-emphasize natin yun or matandaan natin yun when solving these kinds of triangles. Ano ba yung law of sines? So if we have this oblique triangle is actually an obtuse triangle because we have this obtuse angle here. So paano natin ma-apply yung law of sines? Law of sines, ito yung kanyang equation. Now basically, kung titingnan mo dito, A over sine alpha. A, this side, over the sine of the opposite angle. Another thing is B over sine beta. Yung side B over the opposite angle ng side na to, which is angle beta, katapat niya na side or atbang niya nga side. And C over sine gamma. So this side C, over this angle, opposite angle na gamma. So basically what this means is the side divided by the sine of the opposite angle are equal for an oblique triangle. So kailan natin magagamit ito? So when we are given two angles and a non-included side. Second is given two sides and a non-included angle. So anong ibig sabihin nito? Makikita natin mamaya through an example. So first example. So given the triangle below, solve for the value of side C. Okay? So you have this triangle. Okay? So we have these two angles and this side. So this actually belongs to the criteria na ma-applyan siya ng law of sines because given tayo ng dalawang angle and a non-included side. Dalawang angle and this side. Pag itong side na to ang naging given, so meaning nito, we have two angles and an included. Okay? So this is the included side. Ito naman, kung B yung given, at ito, this is considered to be a non-included side. Pero basically, yung ibig na sabihin nito, yung hint mo na a-applyin mo siya ng law of sine is pag given ka ng angle at yung katapat niya na side is also given. So yan yung primary hint natin na applyin natin ng law of sine. Kumplituhin lang natin yung triangle. So kanina ito lang yung given. Lagyan natin ng angle alpha dito, side C dito, at side A naman dito. Now, for the solution, using the law of sines, so again, ito yung general formula natin, substituting the values, okay? So yung B, tingnan natin dito, B is equal to 7, so sinubstitute lang natin dito, beta is 35 degrees, okay? Then yung C, din pa natin alam, sine gamma, gamma is 105 degrees, okay? Now, kung mapapansin nyo dito, wala tayong value ng side A, wala din tayong value ng angle na alpha. So, pwede natin itong hindi gamitin sa ngayon. Okay? So, hindi natin gamitin muna yun. We focus on these two parts of the general equation. Now, to solve for side C, which is yun yung hinahanap sa problem, okay, we just cross-multiply itong sine 105. Nasa ilalim ng C, pag i-cross-multiply natin, pupunta siya sa ibabaw. Okay? So, magiging 7 times sine 105 over sine 35 is equal to C. And therefore, pag kinalculate natin yan using your calculator, ito yung lalabas na value, 11.79 units. Okay? So, meaning pala, itong value na to is 11.79 units. Now, you try. Solve the length of side A and angle alpha. So, try ninyo. Paano nyo masosolve yung side na yan at yung angle alpha? Now, next, for our second example. So given the triangle below, solve for the value of angle beta, alpha, and side A. Okay? So ano ba yung, saan ba yan? Dito. Okay? So ito naman, itong problem na to, we are given two sides, okay, and an angle. Okay? So again, this is an example of a given two sides and a non-included angle. But basically, again, yung hint lang natin dito is pag given ka ng angle at yung opposite niya na side is also given, yan yung primary hint mo na applyan natin ng law of sines. Okay? Now, let's complete the triangle. Lagyan natin ng labels. So let this given angle be gamma. This side be side C. Ito naman side B. Then this is side A, alpha, then beta. Now for our solution, again using the law of sines, substitute lang natin yung values. Okay? So itong dalawa, walang value. 4.7 over sine beta, okay, is equal to 5.5 over sine 63. Okay? So again, walang value yan, hindi natin magagamit. Okay? Then to solve for sine beta, angle beta, what we will do is itong sine 63 na nasa ilalim ng 5.5, because multiply natin, pupunta siya sa ibabaw. And then, itong sine beta, pupunta siya sa ibabaw, while itong 5.5 pupunta sa ilalim ng 4.7, which is, yan yung nangyari dito. Sine beta nasa ibabaw na, then 5.5 nasa ilalim ng 4.7. Take the inverse trigonometric function ng sine, para matira na lang dito is beta na lang. So, arc sine ng makukuha mo dito, okay, will result on the value of beta, which is 49.59 degrees. So, ito palang value na to is 49.59 degrees. Now, how do you solve for angle alpha? Yung beta na-solve natin using law of sines. But what about angle alpha? Okay? So, to solve for angle alpha, alam natin that the sum of the angles inside the triangle is 180 degrees. Okay? So, i-substitute lang natin to. Yung beta, 49.59. Yung gamma is 63. Yan. Then, lipat natin sa kabila. Magiging negative. And we get the value of alpha, which is 67.41 degrees. Okay? Now, having solved the value of alpha, makukuha din natin tong value ng side A. Okay? So, kung napapansin nyo dito, parang domino effect. Okay? Solve mo muna yung isa, then pag na-solve mo, so-solve mo yung kasunod na missing value, then saka mo masosolve yung next na unknown value. Using the law of sines, okay? So this time, itong side A na lang yung hindi natin alam yung value. Okay, pili lang tayo. It's either itong part na to, i-equate natin dito, or itong part na to, i-equate natin dun sa this part, okay? But for our solution here, i-equate natin siya dito sa pangalawa. Okay, to solve for A, side A, we just cross-multiply this one, okay, sa 4.7. So, pupunta siya sa ibabaw, divided by sine 49.59. Pag i-type nito sa calcu, kung sakto yung ating magsasolve, pag-input, we'll arrive on the same answer that side A, okay, side A ito, is equal to 5.7 units. Okay? Now, what I want you to look at here is, ano yung relationship between the angles and the sides. Okay? Titingnan mo yung side A, 5.7, yung katapat niya na angle is 67.41 degrees. Yung side B naman, 4.7, yung katapat niya na angle is 49.59. Side C, 5.5, yung katapat niya na angle is 63 degrees. What conclusion can you create between the sides and the opposite na angle niya? Pag mas mababa yung angle, ano yung napapansin niya sa side? Okay? Is it larger or smaller? Things to remember when applying the law of cosines. Okay? Yung general formula ng law of cosines is ito. So, tatlo. Okay? It's either ito, or ito. Now, kung mapapansin nyo sa formula na to, okay, notice that C, okay, when you use C on the left side of the equation, dun sa kabila naman, ang gagamitin mo na angle will be opposite to side C, which is gamma. Okay. Dito naman, A, okay, yung angle na gagamitin mo dito sa last will be alpha. Okay. And on the third equation, ito, kung ito yung gagamitin mo, B, yung gagamit mo naman na angle dito will be beta. Okay? So, yan. So, kailan natin magagamit ito? When we are given two sides and an angle between these two sides. So, binigyan ka ng dalawang side, then an angle between these two sides, and pangalawa, when we are given all three sides. So, we'll have an example para makita natin itong application na to. So, given the triangle below, solve for the length of side Z. Okay? So, yung side Z natin is andito banda. This is an example of you are given two sides and an angle between these two sides. So, we have these two sides, A and B, and an angle between these two sides. Pag ganyan daw yung forma ng given, then this is an indication that we will use the law of cosines. Okay? Now, completing the triangle. So, if this is side A, alpha dito, side B, beta dito, then this is side Z. Okay? Hinahanap. Now, for the solution, using the law of cosines, so ito. So, mapapansin nyo dito, ito yung hinahanap. Okay? So, kaya yung formula naman natin will start with Z. Okay? Z squared equals A squared plus B squared minus 2AB cosine gamma. Okay? This angle. Pag ganitong klase ng problem, madali lang siya kasi automatic isa-substitute mo lang yung mga given values. Okay? So, for this one, yung A is 6.5, yung B is 9.4, okay, then 2AB. So, A, B, then gamma is 131. I-type mo lang to sa calculator. Kung sakto yung pagkaka-input, you will arrive on this particular value, 210.78. Since Z squared pa ito, kailangan natin i-take yung square root ng both sides, okay, to get the value of C, which is 14.5 units. So, you try. You solve for the value of angles alpha and beta using law of sine. So, dito, nakuha na natin yung Z. Okay? But what about the value of this angle and this angle? Sabi dito, gamitan nyo daw ng law of sines para makuha. Okay? So, that will be your challenge for you to solve. Okay? For our fourth example, okay, ito naman. Given the triangle below, solve for the value of angle beta. So, ito naman yung application ng law of cosine wherein we are given three sides. Okay? So, we are given all three sides. Walang given na angle. So, how do we solve for the angle? In this case, pinapasolve sa atin yung angle beta. Okay? So, since this is side B, automatic yung angle beta will be opposite of this side. Okay? Dito natin beta, gamma, and alpha. So, for the solution, again, we use the law of cosines. Okay? So, since beta yung hinahanap, this is beta, automatic yung sa kabila will be side B. Since given yung all sides, okay, given yung B, given yung A, given yung C, mas mabuti, ilipat natin yung A squared at yung C squared sa kabila. Magiging negative. Okay? So, may iwan yung negative 2AC cosine beta. Now, after natin malipat ito, okay, para maiwan yung beta dito sa kabila, kailangan natin i-divide both sides by negative 2AC. Okay? Maiwan yung cosine beta. So, yun yung gagawin natin dito, or ginawa natin dito. So, magka-cancel out yan. Maiwan yung cosine beta. And then we substitute the value. Yung B is 5. Yung A is 8. Yung C is 9. Then, negative 2 times A, which is 8, and C, which is 9. So, pag kinalculate nyo to, the answer will be 0.8333, okay, is equal to cosine beta. Since pinapasolve sa atin yung beta, we take the inverse trigonometric function of this cosine, okay? So, we take the r cosine on both sides. Magka-cancel ito. Okay? And may iwan yung angle beta, okay, which is equal to 33.56 degrees. Meaning, ito pala is 33.56 degrees. You try. Solve for the value of angles alpha and gamma using law of sines. So again, you complete the solution by finding the missing values, yung alpha pati yung gamma for this problem. Okay? Now, looking back, ma-apply ba natin the question is, ma-apply ba natin yung law of sines or law of cosines sa right triangle? Kasi kung ma-apply yung mga formulas na yun, bakit ko pa i-memorize yung Pythagorean theorem, bakit ko pa i-memorize yung Sokotowa, Choshakaw, okay? So, balikan natin yung example problem natin last time involving yung si Timmy, okay? Yung buwis buhay natin na character. Kung naalala nyo, ito yung ating triangle ng time na yun. Okay? Now, for the solution, apply natin ngayon ng law of sines. So, in this case, 75 over sine alpha, 75 over sine 30, so 75 meters over sine ng opposite angle, which is 30, is equal to J over sine 90, okay, is equal to C over sine gamma, which is equal to 60. Now, bakit naging 60 yan? You analyze this triangle. Okay, paano naging 60 yung value nito? To solve for the value of J, okay, which is one of the unknowns, the length of the line of sight, okay, how long is the line of sight? All we need to do is, huwag muna nating intindihin itong third part of the law of sines. Focus here, and then we cross-multiply this one sa kabila. So, magiging 75 sine 90 over sine 30 is equal to J. Pag in-input nito sa calculator, J will result to 150 meters. Now, next is, what about the value of C? Okay, so how do we solve for the value of C? Alam natin kanina na naging 60 ito. So, is equal to C over sine 60 degrees. Okay, we cross-multiply this one, yung sine 60 sa kabila, magiging 75 sine 60 over sine 30, which gives us, this one is already, dapat ito, C na ito, C is equal to 129.9 meters. Okay, so 129.9 meters. So, comparing these answers, dun sa answers natin last time, using yung Pythagorean theorem, the 6 trigonometric function values, so, we actually arrive on the same answer, meaning, yung law of sines pala is actually applicable whether it's an oblique triangle or a right triangle. Now, you figure this out. Test the law of cosines to right triangles. Is it also applicable? So, that's for you to find out. And so, I'll see you on the next video. This is end of part 1, lesson 2 of 3 in trigonometry. So, for our next video, okay, we will be dealing with word problems involving oblique triangles. So, that will be all for now. See you on the next video. Good morning and welcome to a lesson on spherical trigonometry. The intended learning outcome for this session are as follows. Understand why we need to learn spherical trigonometry. Next is understand what is a spherical triangle, its related terms, and its various properties. Third is to understand how to use Napier's rule for solving right spherical triangles. And lastly, to solve problems involving right spherical triangles. So without further ado, let's start. First is, why do we need to learn spherical trigonometry? Okay, shown is an advertisement of Philippine Airlines showcasing the capabilities of their new set of aircrafts. Okay, now what I would like to focus here is the path which the airplane takes. Okay, this one. As you can observe, it is not a mere straight route. Okay, this one. Unlike what we were solving last time. Any guess why the path is like this before we proceed? Give you 5 seconds to think about it. Okay, the map shown here is a 2-dimensional representation of a 3-dimensional Earth. Okay, itong nakikita nyo dito na mapa is just a representation ng hugis bola natin na Earth. Okay, therefore, if your answer is because the Earth is a sphere, specifically an oblate spheroid, then you are on the right track. The Earth is a sphere, and our lesson is spherical trigonometry. Our lesson is related to latitudes and longitudes. Okay, this subject is related also to astronomy, the geosciences, and for our purposes, in the context of your course, which is Bachelor of Science in Marine Transportation, Navigation. Now, few terms before we proceed. Okay, So first is the great circle, okay, which is a section of a sphere that contains a diameter of the sphere. While sections of the sphere that do not contain a diameter are called small circles. So ito yan. In this illustration, ito daw nasa gitna na circle. This is known as the great circle. Anything na hindi sa gitna, okay, na circle, we call this small circles. Okay? Now, to better illustrate this one, isipin nyo na naghihiwa kayo ng sibuyas. Okay? Yung mga circles na nakikreate natin dun sa ibabaw, especially kung nasa ibabaw ka pala nagsaslice, are called small circles. Pero pag dumating ka na sa gitna, especially dun sa pinakagitna, that's the time you are creating a great circle. Now, para mas madali nating makuha kung ano ba yung ibig sabihin nitong great circle at small circle, we have an illustration here. So this is the longitudinal lines and this is the latitudes. Okay? Sabi dito, all longitudes are blank circles. Okay? Tingnan niyo itong picture na to, illustration na to, and think about it for a second in relation to the definition that was stated in the previous slide. All longitudes are blank circles. In this picture naman, for the second part, all latitudes are blank circles, except for blank. Okay. Now, if you answered here that all longitudes are, okay, kung titingnan mo dito, great circles, then sakto yan. Okay. Dito naman, if you answered all latitudes are, okay, small circles, except for the equator, okay, then that is also correct, since the equator is a great circle. Now that we have established what great circles and small circles are, let's discover what are spherical segments. Okay? Now, according to the definition, a spherical segment is a finite part of a great circle. Okay, to illustrate this point or to illustrate this definition, let's say for example, okay, we have this great circle, ito nasa gitna. Let's say for example, within this great circle, we have 2 points. Point A and another point B. Okay? If we interconnect these 2 points together, okay, this is now what we call a spherical segment. Okay? A finite part of a great circle. Now, if we have 3 spherical segments, okay, which forms a triangle, then we have what is called a spherical triangle. Okay, which is basically a group of 3 spherical segments. So ano ba yung forma nitong spherical triangle and how does it differ in form to the triangles that we have already discussed, yung right triangles as well as the oblique triangles? Paano nagkakaiba ito sa forma? Okay? So we have a video here. Try to look at the various forms that our spherical triangle takes. Okay? So this one is a spherical triangle. This is also a spherical triangle. That is a spherical triangle. Yan. And lastly, yan. Okay? So those are all forms, okay, of spherical triangles. Okay. Now that we have learned what are spherical triangles, okay, what is a spherical segment and what is the great circle, let's go to the parts of a spherical triangle. What are the various parts of this particular triangle? Okay, yung pinakita natin kanina. So una, itong triangle na to also have sides represented by these small letters A, B, and C. Kung titingnan natin dito sa drawing, this one, ito, at ito, okay, these are the sides of our spherical triangle. Now, this triangle also has angles represented by the capital letters A, B, and C. Okay, this angle A, this angle B, and this angle C. Okay, so those are basically the parts of our spherical triangle. Now that we have learned the parts, let's go to the properties. Kailan ba natin masasabi, okay, na itong triangle na to na sinusolve natin is a spherical triangle? Okay, so the first property of a spherical triangle is the sides of a spherical triangle are measured in degree, minutes, and seconds. Now this is very important na differentiation between the triangles that we have already solved in the past lessons and this topic in spherical trigonometry. Na yung sides ngayon is hindi na in units of meters, kilometers, and nautical miles. But here, sinasabi dito that sides of the spherical triangle is in degree, minutes, and seconds. Kaya we had our lesson in conversion natin from degree to minutes, okay, degree to radian, Okay? Ito daw, the sides A, C, and B is in degree, minutes, and seconds. Now, what is the implication of this? In the illustrations that we have presented kanina, we learned that latitudes, okay, longitudes, related to spherical triangles. And kung ating babalikan, itong latitudes, itong longitudes are actually measured in degrees. Okay? So, marapat lang na itong mga sides na to, A, B, at saka C, is actually in the unit of degree, minutes, and seconds. Okay? Now, for the next property, no side can exceed 180 degrees. Meaning, itong A, B, and C, okay, pag nag-solve tayo later on, hindi siya po pwede na maglagpas ng 180 degrees. Kailangan less than or equal to 180 degrees. Okay? The next property is the three angles of a spherical triangle must together be more than 180 degrees and less than 540 degrees. Okay? Mas madali natin itong maintindihan in equation form. So, ang sinasabi lang dito sa third na property is that pag inad daw natin yung angle A, B, at saka C, kailangan yung sum or yung total, okay, mas malaki siya sa 180, pero less than siya ng 540. Sir, pwede ba equal ng 180? Pwede ba equal ng 540? Hindi, okay? Because the symbol here, wala tayong equal sign. Those are the properties of our spherical triangles. Now, it is important to remember these properties in order to check our answers later. Okay? So bear these properties in mind. And with that, let's start with the simplest of all spherical triangles, which is the right spherical triangle. A spherical triangle with one angle equal to 90 degrees. So kung titingnan nyo dito sa illustration, madali yung malalaman na right spherical triangle yan because of this right angle here. Now, how do we solve this type of triangles? In spherical trigonometry, in solving right spherical triangles, we will be using what we call the Napier's rule for right spherical triangles. Basically, kailangan natin ito. Okay? Kailangan natin itong matandaan, kailangan natin itong ma-drawing, okay, before solving anything involving right spherical triangles. Okay? So ito yung ating gagamitin to solve right spherical triangles. So sabi dito, use this to solve these types of triangles, yung may right angle. Okay? Now, ano ba itong Napier's rule? So basically, meron ng dalawang rule si Napier. Una is yung tinatawag na sin cos op rule. Yun, ano ba itong ibig sabihin ng sin cos op? It states that the sine of an unknown part is equal to the product of the cosines of the opposite parts. So, mas madali natin itong maiintindihan through an example. So, example, hindi natin alam yung value ng side A. Ito. Okay? If this is unknown, okay, using this tool, okay, pag ito daw unknown, sabi niya dito, the sine of an unknown part. So, sine ng A is equal to the product of the cosines of the opposite parts. Ano ba yung opposite nito? Sabi atbang, ani. Ano ba yung katapat? So, katapat nito is itong 90 degrees minus A at itong 90 degrees minus A. Sir, paano mo nasabi na katapat yan? Because itong natitira dito, 90 degrees minus B, at saka itong B na maliit, is katapat or katabi. Okay? So, ito yung katapat. So, basically, pag in-apply natin yung sin cos op na rule, sine of the unknown part is equal to the product of the cosines of the opposite parts. Kaya 90 minus C yan, at saka 90 minus A. Okay? Now, another one. What if ito naman yung hinahanap? 90 degrees minus C or yung side C yung hinahanap na value ng ating spherical triangle. Okay? Pag ito naman yung hinahanap, using sin cos op na rule, sine of an unknown part, so sine nito, sine ng 90 degrees minus C will be equal to the product of the cosines ng opposite na parts. Opposite to this is A and B. So that is why this is our answer or this is our equation to solve for this particular unknown value. Okay? Now since this is not complete, you try. Use Napier's sin cos op rule to find the equivalent equation if the missing parts are this one, and this one respectively. Now moving on to the second rule of Napier. Okay? The second rule is what we call sin tan ad rule. Okay? It says that the sine of an unknown part is equal to the product of the tangents, kung kanina cosine, ito naman tangents. Pero ngayon, of the adjacent parts. Again, for an example, kung ito yung hinahanap, the sine of an unknown part, okay, the sine of an unknown part is equal to the product of the tangents, okay, of the adjacent parts. So, katabi ng A is 90 degrees minus B at saka itong B na maliit o yung side B. So, that is why this is our equation. Next naman is, what if ito yung hinahanap? Okay? Using sin-tan-ad rule, the sine of the unknown part is equal to the product of the tangents of the adjacent parts. That's why it's tangent 90 minus B times tangent 90 minus A. So basically, yun yung sin-tan-ad rule naman. Okay? So again, meron tayong mga kulang na equations dito. Ito, hindi pa natin na-solve. This one and this one. So kayo na bahala mag-solve niyan. Okay? To complete the 5 equations corresponding to the utilization of sin-tan-ad rule. Okay? Now, let's go to an example para ma-apply natin kung ano bang ibig sabihin ng sin-tan-ad rule at sin-cos-op rule at kailan natin siya magagamit. So, okay. So, for the first example, so given the spherical triangle shown on the right, this one, okay, if side A is equal to 50 degrees and side C is equal to 80 degrees, determine the value of angle B, angle A, and side B. So, given daw tayo nitong A na side at saka C, this one. Determine the value of angle B, ito, angle A, at side B. Okay. Now, notice the property, the first property which is yung sides naka-degrees. Okay? A daw is 50 degrees, ito naman is 80 degrees. Now, to solve for angle B, okay, for our solution, using Napier circle, okay, so ito yan. Isolve na natin itong angle B, this one. Okay? Pero take note, yung given sa atin is yung side A at side C. Saan ba yan dito sa Napier circle? Ito yung hinahanap. Ang given sa atin, side A at saka side C. Itong dalawa. Okay? So, kaano-ano ng 90 minus B? Itong dalawang given. Okay? Kung ang sagot ninyo ay katabi, adjacent parts, then we agree that we will be using here the sin-tan-ad rule. Okay? The sine of the unknown part is equal to the product of the tangents of the adjacent parts. Kaya naman, ito yung gagamitin natin na equation to solve for angle B. Okay? Now, substituting the values, alam natin that A is 50, C is 80. Yan. So, ito yung lalabas. Then, simplifying further, 90 minus 80 will be 10 degrees. Okay? So, tangent 10 times tangent 50, lalabas will be this decimal. To solve for B, we take the inverse trigonometric function of sine. So take arc sine of both sides. This cancels out. Yan. Matitira sa left side of the equation will be 90 minus B. Okay? At dito naman is the arc sine of this decimal. Okay? So 90 minus B, take the arc sine, will be 12.13. Itong negative B, lipat natin sa kabila, magiging positive. Ito naman, lipat natin dito sa left side, magiging negative. Yan. So simplifying, we have B is equal to 77.87 degrees, or in degrees and minutes, it will be 77 degrees, 52 minutes. Now, paano yan naging ganyan? Okay, you just press this button on your calculator. From decimal, automatic magiging ganito yung form niyan. Okay? Actually, meron pang seconds yan na i-display. Okay? Because this button means degree, minutes, then seconds. Meaning it's an auto conversion to degrees, minutes, and seconds na unit. Okay? So that is in solving angle B. Now for your part, tatlo yung hinahanap. Okay? Nasolve na natin tong angle B. What I want you to do, okay? Since dalawa lang naman yung Napier's rule, okay, I want you to solve for angle A and side B. Now, after you have solved, you check your answers using the properties of spherical triangles. Okay? Ano-ano ba yung properties? I-recall ninyo or balikan nyo sa video para ma-check ninyo after you have solved A and B. Okay? Is it correct? Is it in accordance with the properties of spherical triangles? And comment down below your answers para matingnan din natin. Okay? Now, for those who will be commenting, the first 5 commenters on this particular activity, okay, I will be So wala naman akong pwedeng maibigay sa inyo kasi naka-quarantine tayo. So sandamakmak na shoutout na lang yung ibibigay ko on our next video. So bali, ikakat ko yung inyong comment and then isa-shoutout natin. Okay? Okay, so that will be your prize for commenting in this particular video. So that would be all for this session. I hope you've learned something. And by the way, for those who have not yet subscribed to this channel, subscribe and leave it a thumbs up if naging helpful itong video na to sa inyo. And I'll see you on the next video. Good morning and welcome to a lesson on solid mensuration. In this video, you will be able to understand why we need to learn solid mensuration. Second is to differentiate parameters in solid mensuration, specifically perimeter, circumference, area, and volume. Third will be to understand the equations for solving these parameters. Okay? And lastly, to solve problems involving perimeter, circumference, and area. So without further ado, let's start. Now, few terms before we proceed. Okay? So first is, what is solid mensuration? So solid mensuration is the branch of mathematics which studies the measurement of three-dimensional objects and their parameters like perimeter, area, and volume. Okay? So on the course of the topics that we will be discussing, hindi mawawala itong pagsosolve natin ng perimeter, area, pati itong most especially volume. Okay? Now, common shapes. Okay, let's review first the common shapes. Okay, so we have a triangle, the different quadrilaterals. Okay, yan. Then we have the circle and all other flat surfaces. Now, let's talk about perimeter. Perimeter is defined as the distance around two-dimensional shapes. Okay. Another definition is, it is the sum of all the straight sides. Okay. So if we have this triangle here, to solve for the value of the perimeter, okay, since it is the distance around two-dimensional shape, in this case a triangle, so we just add, okay, we just add or take the sum nitong tatlong sides na ito. There is a highlighted word here, straight. Okay? So pag yung side daw ng isang two-dimensional object is straight, we refer to the sum of those sides as perimeter. But what if yung ating kinukuha is an arc distance? Okay? So in that case, we will be calling it circumference. Okay? So it is the distance around naman a circle which has no straight side. Now, moving on. So what about the term area? Okay, so area is defined as a measure of how much space there is inside a two-dimensional shape or flat surface. So we have an example here. So kanina, we talk about perimeter, i-add lang daw natin yung sides. We talk about circumference, kunin lang daw natin yung distance around the circle. But when we talk about area, okay, here we do not talk about length or yung haba, pero yung space. Sabi dito, space sa loob ng ating two-dimensional na object. So instead of this length or instead of this distance, yung kukunin natin is itong space, okay, inside this particular shape. So that's for area. Okay? Now what about the term volume? Okay. Kung sinabi namang volume, it is a measure of how much space, okay, is inside a three-dimensional object. Okay, kung ang area is defined as the space within a two-dimensional object. Ito naman is space inside a three-dimensional object. So to illustrate that point, okay, so balikan natin. If we have this triangle, at ito yung kanyang area, okay, so magiging three-dimensional object lang yan, okay. This triangle is presently a two-dimensional object. Magiging three-dimensional object lang yan pag nilagyan natin yan ng thickness or height, okay. So to illustrate that point, for example, we have this particular shape, okay, two-dimensional object which is in the shape of a triangle. Pag linagyan natin yan ng thickness or height, okay, yan, then we have now a certain object, okay, with a what we call volume, or which has a space inside. Kaya nga natin napapasok yung chocolate sa loob ng karton na ito. Okay? Another thing is for a circle, for example. So marami tayong objects na sa ibabaw nakikita natin merong circular na shape. Pero pag nilagyan na natin yan ng thickness or height, okay, which is the third dimension, then you can now have this, for example, sardine can. Okay? So here, this has now what we call a volume. So basically, pag sinabing volume, pwede na nating sidlan yung isang bagay. Okay? Because there is a space inside these objects. So now that we have discussed ano yung kaibahan ng perimeter, area, and volume, okay? Now let's go to the various equations in solving the different perimeters and areas of two-dimensional objects. Okay. So for triangles, so alam natin that a triangle, so katatapos lang natin ng trigonometry. Okay. So alam natin that this is the shape of a right triangle. So for a triangle, okay, so perimeter is basically the sum of all sides. So i-add lang natin side here plus side dito plus side dyan. That is the perimeter. So napakasimple lang. Now for the area of a triangle, okay, so again we are concerned sa area nung space na nasa loob ng ating, okay, shape. For the area, it is equal to 1/2 base times height. Now, anong ibig sabihin nitong base? Okay. So, base is basically yung side kung saan nakatayo yung ating triangle or yung ating shape. So, in this case, in this particular side, ito yung nagsisilbing base ng ating shape. Okay? Which is in this case, a triangle. So, ito daw yung formula ng area ng triangle. It's basically 1/2 base times the height. In this case, yung height natin is yung side A. Okay? So, kaya yung area for this particular triangle will be 1/2 ng B, which is our base, times the height, which is A. Now, special cases of triangle. So, kanina, given tayo nitong triangle na to. Okay? Now, what if magdagdag tayo ng this triangle with a base of D? Okay? Now, this is still a triangle. Okay? But because we added this particular triangle, mas umaba or mas lumaki yung ating triangle na kinukunan ng area ngayon. Now, for this triangle, applicable pa rin yung formula natin kanina or yung equation natin kanina in solving for the area. Kaso lang, magbabago ng konti yung ating, okay, equation or yung ating isa-substitute for the base. Okay? So, in this case, since nagdagdag tayo ng base na D, okay, since ito na ngayon yung kinatatayuan ng ating triangle. So, this whole thing, okay, from here up to here, this is now the new base. Okay? So, since ito na ngayon yung new base, marapat lang na palitan natin yung formula. Okay? That the base is now B plus D times the height na A pa rin. So bakit naging ganito yung formula for this particular triangle? So basically, ang nangyari dyan is ganito. Okay? So you have the area for this small triangle is 1/2 base times height. 1/2 D times A. Okay? Ito namang triangle na to, okay, it is 1/2 base, which is B, times A. Itong part na to is para dun sa maliit na triangle, at ito naman para sa bigger triangle. Okay? Now, another formula or another equation para ma-solve yung area ng triangle is when we are given the three sides of our triangle. So in this case, hindi given sa atin yung height ng triangle, but we are given the three sides. So for this particular case ng triangle, ang i-apply naman natin dito is what we call the Heron's formula. Again, when all sides are given. So ano itong Heron's formula? So basically, first is you solve for the half of the perimeter of the triangle. Okay? Which is also known as semi-perimeter, or meaning, semi means 1/2. So half ng whole perimeter ng ating triangle. So in this case, the semi-perimeter, which is represented by this variable s, is equal to the perimeter of the triangle divided by 2, since semi, half of the perimeter. So after nakuha natin yung semi-perimeter na yan, then we can substitute this to what we call the Heron's formula. Okay? So the area of the triangle now is equal to the square root, okay, ng s times s minus 1 of the side times s minus 1 of the side times s minus 1 of the side of the triangle. Okay? So basically, ganito naman yung pagkuha ng area ng triangle when you are given the sides. Again, no height was given. Okay? Now, that's all for triangles. Let's move on to another shape. Okay? Quadrilateral. So basically, it means 4 sides. Quad and lateral. Okay? So 4 sides. Now, if we have this quadrilateral, okay, to solve for the perimeter, madali lang. Again, you just add, okay, the 4 sides, the 4 straight sides, and you have the value of the perimeter. Okay. Now, what about the area? Okay. So this is the area of our quadrilateral. Okay, the area is equal to base times height. Now, wait. Parang familiar sa pandinig. Base times height. Kung alala nyo kanina, yung formula for the area ng triangle is 1/2 base times height. Now, ngayon naman for quadrilateral, it's actually base times height. Now, kung titingnan natin dito, okay, paano naging ganito yan? Okay, if we try to look at it, itong ating quadrilateral is actually composed of 2 triangles. So, kaya naging base times height na ito. So, basically, the area of a quadrilateral is equal to 2 times the area of a triangle. So, kanina na laman natin that area of a triangle is 1/2 base times height. I-times lang natin sa 2. So, this will be cancelled out. Kaya naman, yung area for a quadrilateral is this 1. Just multiply the base times the height. So, in this case, the area of this quadrilateral is just D times A. Or pwede din, since A is just equal to C, D times C. Okay? So, ganyan lang. Now, Lahat ng quadrilaterals, since maraming klase ng quadrilaterals, okay, lahat ng quadrilaterals or yung four-sided na polygon, okay, lahat niyan is yung area base times height. Example ng quadrilateral na ganito yung formula is yung rectangle, okay, square, okay, parallelogram, and rhombus. Now for these two quadrilaterals, dito sa dalawa, okay, careful lang tayo. Yung height na gagamitin natin dito is what we call the perpendicular height. Okay? So kung napapansin nyo dito sa parallelogram at rhombus, tabingi yung kanyang sides. Okay? This one, tabingi. Okay? So yung gagamitin natin na height is from here up to here. Perpendicular height, meaning mag-create siya ng 90-degree angle, okay, to the base of our, okay, quadrilateral. So this is now our perpendicular height. Ito yung isa-substitute natin dito sa formula. So the base times this height, yan yung area for these two types of quadrilaterals. Now, what if naman hindi given yung base at saka height, pero given tayo ng diagonals? So in this case, given tayo ng diagonal 1 and the length of diagonal 2. Okay? Now kapag binigyan tayo ng diagonals, yung area naman ng quadrilateral will be equal to 1/2 diagonal 1 times diagonal 2. Okay? So yan yung formula in solving this particular shape. Okay? Now, another quadrilateral na hindi base times height yung formula will be the trapezoid. Now, for a trapezoid, meron siyang dalawang bases. Okay? Base 1 and base 2. And this particular perpendicular height. Okay? So, to solve for the area of a trapezoid, yung kanyang formula naman is ganito. Base 1 plus base 2, yung sum, i-divide natin by 2, then saka natin i-multiply sa height. Basically, yung nangyari dito, you take the average ng dalawang bases, okay? Average ng dalawang bases, then i-multiply natin sa height ng ating trapezoid. And that is now the area for this particular shape. Okay. Now, what about circumference? Circumference ng circle. So, before we go to the formulas, okay, let's understand first that a circle, meron niyang center. And from a point on the circle to another point on the circle, passing through the center, okay, yan, we call this the diameter of our circle. Okay. Another thing is, from the center of our circle to any point on the circle, example yan, we call that the radius. Okay? So it's very important na maintindihan natin ano yung pagkakaiba ng dalawang ito and how are they related also to each other. So for example, sa circumference ng circle, it is just equal to 2 times the radius, okay, times pi. Or, another formula will be diameter times pi. Now, kung titingnan natin dito, bakit naging diameter times pi? Kung titingnan natin, itong diameter is just actually equal to this radius plus this radius. Meaning, itong 2r pala is just equal to the diameter of our circle. So, diameter times pi. Now, for the area of this circle is actually equal to pi times radius squared. Nalaman natin kanina na dalawang radius is diameter. Meaning pala, pag kinuha ko yung kalahati ng diameter, So I will have also the radius. Kaya naman dito, instead na r squared, pwede mong palitan d divided by 2 squared. Meaning half ng diameter, which is still equal to the radius. Okay? Yun yung square natin dito. So this is the formula for the area of a circle. Now, what about special cases for circles? So, sector of a circle, kung mapapansin nyo yung sector, it is in a shape of a pwedeng pamaypay or pwede ding pizza. Okay? So, the formula for the area of a sector of a circle is this one. 1/2 radius squared times this angle. Okay? We call this the central angle of our sector. Now, this theta, okay, kailangan yung value niyan must be in radians. So, kadalasan ng mga makikita natin na given dito is naka-degrees. So, kailangan pag pinasolve sa atin yung area ng sector, i-convert muna natin to radians bago natin i-substitute dito sa formula na to. Okay? So, klaro yan. Now, next is for the segment of a circle. So, the segment of a circle is actually just a part of this sector. Kung papansin nyo, ito lang yan. Dito, hanggang dyan. So, meaning, it is just part of the sector of a circle. Tinanggal lang yung triangle na part. Okay? Tinanggal lang itong part na ito. Okay? So, basically, yan, tinanggal lang yan. Ito yung base ng triangle. Meron tayong height ng triangle. For the area of this segment, just equal to area ng sector. Kaltasan natin ang area ng triangle. So, substituting the values for the formula, area ng sector is 1/2 r squared theta. Then, yung area ng triangle, as discussed kanina, is 1/2 base times height. And this is now, pag nakaltas natin yan, sa area ng sector, makukuha naman natin yung area ng ating segment. So those are the formulas related to perimeters, areas, and circumference. Now for the sample problems, as an application of these formulas, I'll be putting some links in the description box below, so make sure to check it out. And that's it. If you find this video helpful, please leave it a thumbs up, click subscribe, and ring the notification bell so that you will be updated on our next uploads. With that, thank you for watching and see you on our next video.